Dream Flake, we're going to be looking at Grasshopper and Houdini, and bringing Grasshopper to Houdini using HouGh. Software is Houdini 18 or above. You can use Apprentice, which is the free Houdini. You need Rhino 7 Grasshopper. You need these plugins here and KeyShot. I want to just remind that this isn't an intro to Grasshopper or intro to Houdini course. However, it's not a very difficult course to follow, but you may not understand everything if you've not touched these softwares before or you haven't used them so much. And that's okay, because you'll have a recording to go back to whenever you want. And you can see here on our requirements to see our resources category for free intro courses on the software. So on our website, if you ever want, you can go to the resources category, and from there you can find all kind of the best intro to courses that are free. For instance, if you want to get into Houdini, you have Houdini Isn't Scary and Intro to Houdini. Really great series to watch for like the super basics, and same for Rhino and Grasshopper. So definitely check that out if you want to get into like the super basics. I'm just going to cover the workflow I'll be showing as clearly as I can. And let's see. And yeah, just a reminder, that you'll have a recording, and the recording will be emailed after. So if you can't keep up, it's okay. Don't worry about it. It's not the end of the world, but we do need to just keep going. We can't go back for every little thing just to get through the material. Yeah. So as long as you have all that information, should be good. And so lastly, I just want to say, let me just take this here. If you're interested in our masters, before we'll have an open day, but we recently did a kind of presentation interview, which you can see here. I'll put on chat at YouTube. If you're interested, we have a few students presenting their work there so far, and we have a kind of talk about it. And also just to remember to, for now, like I'm not doing anything with raising hands, so don't do any raised hand stuff. If you have a question, just ask the question. So let me just, okay. So yeah, and then just make sure you follow, obviously Design Morphine. I just put in chat, follow me and CDNext. Those are the 3 Instagrams there that you should follow to keep up to date with all this stuff. Okay. All right. Add me up on foundation, please. No, sorry. Here's, I just want, before we, oh yeah, so prizes, there's 3, 4, 5 prizes. And they're for live attendees. They'll be announced afterwards, probably when we send the recording. We'll reach out to the winners. If we don't reach out to you, just means unfortunately you didn't win. There's no reason to contact us. If you've won, we'll let you know. There's three people will get free entry to all 4 next webinars. One person will get a foundation.app creators profile to mint NFTs, and another person will get a full free license of KeyShot from KeyShot themselves. They've provided a license as a prize for this webinar. So before we get started, I'm going to drop this Dropbox link. Now, in this Dropbox link that I'm going to put right now, you do not need to download it right now, and I suggest you don't, because if everyone tries to download it at the same time, you'll like get our Dropbox temporarily blocked. The link won't work. So I'm putting it there, but again, you do not need to download anything now, right? So basically, in that Dropbox, there's these files, but they're all empty. There's nothing there. They're just the files I'm going to be working on. So as I work, I'll save And if you fall behind, you can go to the Dropbox and download like at the point I'm at. Okay, but for right now, there's nothing. They're all empty. There's literally nothing in those files. Okay, so you don't need to download them now. Download things if you start to fall behind or something, you want to catch up, you can just download it. And then of course at like the end, those will be the final files that you can okay. So again, no reason to download them now and crash the Dropbox. Okay, so let's get started here. So first thing we're going to do is I'm just going to rename this layer guides. I like to use the name guides. Okay, so and I'm also just going to turn off my camera just because just in case there's any latency, it usually makes things run smoother. So let me just turn off my camera. Yeah. Okay. So again, remember Q&A, please, if you have a question about the webinar as we're going. So first thing I'm going to do is I'm going to basically I start this whole process just by drawing two basic curves, and that's going to be basically we're just going to draw 4 curves, and that's basically going to be the only manual input we're going to have in this entire process, which is pretty cool, I think. So I'm just going to start by making some curve with the nerves curve here, and I'm just going to draw something that's kind of like this, and I'm going to try to stick to what I did in my tutorial just because I know the measurements are set correctly, especially for what I'm doing in Houdini. Although it can be any size, you just will have to tweak the numbers for what we'll do in Houdini. So I just want to make sure what size am I drawing this? I'm at 70. I know in my example I was drawing at like 50. I'm in millimeters, by the way. I know I was drawing in like 50, something like that. So I'm just going to do scale 1B and then click here and just bring it somewhere around there, just to have the size right. And I start the curve down here. Right? So if you do curve start, you'll see that the start point is towards the XY axis. The link for files, I'll share it again, but don't download them yet. There's nothing. They're empty. They're empty files. They're just the files I'm working on. So don't download them until you need them if you fall behind or something. Okay. And then I'm just going to mirror this. Just put it somewhere like that. That's good for now. We'll adjust those and then very shortly. Just want to get 2 curves down. Save. And so in Grasshopper, first thing we need to do is we just got to bring those curves in. So let's get a curve. And we'll those are going to be like basically guide curves for what we're going to do. And the next thing we need rail curves, right? So we're going to like kind of tween along this thing here. We're going to use these as rails between. So I'm just going to make some kind of random curve here, and I started from the left point, right, and I went to right. Knowing about the curve direction is always good. So I'm just gonna do something like that. So let's just say we have something like that. So here we're gonna do set multiple curves. So set multiple curves, and then we're gonna select. I select this bottom one, and then this one here, the other end. I actually just want to Make sure. Okay, just wanted to make sure it was recording. Get paranoid sometimes. Okay, so now I'm gonna get two more curves, and we're just gonna input like the two rails basically, and we'll set one curve. We'll set this left curve here, and then set one curve, and we'll set the right curve here. Okay. And what we're going to do is we're going to do tween through curves along curve, which is a pufferfish component. So tween through curves along curve. Looks like this. And we're going to put these curves, our profiles, right? C, which is curves, set of curves along guide curve to tween through. And we're going to use these as guides. Okay, so you see how it made like the in-between curve, but it's using these as a rail. For those of you, if you don't know, Pufferfish is my plugin, so if you were wondering. So now the factors. Factors are basically numbers between 0, 1, 0 being that curve and 1 being that curve, which are going to represent the divisions between. So we're going to get a range. And a slider. And that's just going to tell us, that's just going to make 10 numbers between 0 and 1 kind of in order. So if I plug that in, you'll see you get something like this. Okay. Can you please make it more understandable? Understandable means what? It's pretty understandable. So then you're going to get a graph mapper. So what this graph is going to let us do, if I right click this and go graph types, Bezier, it's going to let us like determine kind of spacing between those numbers, between 0 and 1. Which curves to set. Yeah, I've explained that if you watch the video, if you watch what's going on live. So set multiple curves, you go 1, 2, enter. This curve here, I set this one that's turning green there. This curve here, I set this one that's going there. And here I'll save it, and you can just download it if you are confused. And so now by playing with this mapper, you can adjust like this, like the kind of spacing of that, right? So, you know, I will give it something like that. So again, and it could be anything. Do what you want. I'm just thinking about what I did for the example images, basically, like kind of settings I did there. So the next thing I want to do is I want to give this like a bit of a more interesting shape, but that's gonna like it might mess up some things, but it's okay because we're basically just using this as a guide, and we'll create something that's kind of cleaner from it. So what you can do is you can then pull these curves around and kind of shape this thing a bit, and you'll get stuff like that. It's okay. So I'm just gonna just shape it how you think like looks cool. It doesn't need to be exactly what I'm doing. And you can change it at any time anyway, so it doesn't really matter. And yeah, then I don't know, maybe I want like this to these 2 points to come like down here. It's okay if you get like these overlaps. I actually thought, though I had some overlaps like that in my example, and they actually ended up looking like pretty cool once they got smoothed together as a mesh. So it's okay. Don't worry too much about it. And you can adjust this thing like all day, really, but we don't want to do that. And maybe I want to make this up here a bit thinner. I don't know, something like that maybe seems kind of cool. Maybe thinner here too. Whatever, any shape you get is good. So save, not attached to the guide. Do you know how to fix it? Well, they might not be exactly, if they're not attached, means things to check are to make sure that your curves are in the same direction. So if I go here, if I type start curve and see like the start of this curve is there and start of this curve, so they're both starting in the same place, right? So these start in the same place, and then these ones here also, like for the start curve, they start from left to right. So that's one thing to check. Make sure that there's like these are starting, these curves are going in the same direction, and these curves are going in the same direction. That's one thing to check. Other stuff to check is just to make sure that you have them, set in here correctly. I think if I did this the other way, I don't know if it works the other way. So it's likely then your curve directions. Shows no graph somehow. Right click, graph types, and select a graph. Okay. Yeah. Okay. So save documents. Okay. So next thing we're going to do is we're going to like kind of clean this up a bit by getting rid of some of the, you can get rid of some of like the overlaps or like clean this up. And what that means is like if I had a shape that was something like trying to mess this thing up, and actually it's actually doing quite a good job of being okay. So let me try to purposely like mess it up a bit. I don't know, if you had something like this, like that kind of condition, which is still kind of okay, but you can do things like extend, but we can do a negative extension. So we get extend curve, extend, and we will get this, but we'll get negative, so negative. So a little kind of trick with a curve extend, if you go negative, you can actually remove from the curve, and we're going to remove from 1 and 2, which is like start and end. And they're on curves or what? Oh, I think I'm removing too much. There you go. So let me select all these, right click, preview off, right? So you see how I'm like removing from it, it gives me an error like once if a curve like fully disappears, like that one there. But we can just do it like to the point where, for instance, we might get rid of or like clean that intersection up a bit. So we can just do it a bit, or not if you want. Like this part isn't totally necessary. I just like to clean it up just a bit. Yeah, something like that. It's cool. If you don't have tween, then you haven't installed Pufferfish. In the center, it's not running long. If you have a curve in the center, it means your curves are not in the same direction. For instance, if I flip this curve, they're going to be like that. Or if I flip this curve, it's going to be like that. So make sure your curves are running in the same direction. These two should be in the same direction, and these two should be in the same direction. Start left, right. Yeah, so it's a single closed curve. We're not using any single closed curves, so don't use any single closed curves because we're not using any single closed curves. We're using 4 curves, as you see here. And make sure your curves are running in the right direction. You see, if I flip it, you're going to get like this weird thing here, right? Because they're tweening opposite of each other. They need to be in the same direction. Okay. So let's just say that this is, if you want to group things, you can select things and then press Control G. And if you want to change the color, you can right click, go to color, and you can make the color whatever you want. I'm just going to group things. Actually, I want to group these as kind of like the inputs. Just make that red, red. Just gonna make these blobs easier for me to remember. I always use like blobs for inputs for some reason. I have no idea why, but I do. Just save, and then I'll just group this. That's like kind of like one. I like to just like group the chunks of like processes, you know. So it should be good. If you don't have Tween, you didn't install Pufferfish. Okay, so make sure you install Pufferfish. So now we have that. What we're gonna do is we're just gonna like remake now the kind of ends of that. So I'm actually just gonna make another layer just so that I can hide this layer. Okay, and we'll just get the endpoints. I just have Tween curve. Okay, please listen carefully, everybody. If you do not have the Tween I'm using, it means that you've not installed Pufferfish. Pufferfish, see there's a tab there, Pufferfish, means you have not installed Pufferfish. And if you installed Pufferfish, then you've done it incorrectly. It comes in an installation file. Make sure you've done things like unblock the file, put the file in the right location, etc. Likely you forgot to unblock the file, and then in that case it wouldn't work, or you put it in the wrong folder for some reason. It comes with very detailed instructions. Just follow them step by step. Often you'll have to do things more than just drag it and drop it in. You probably, a lot of plugins download as blocked. You have to unblock them, which there is instructions in the download of Pufferfish in the installation text. Okay. So start end and then interpolate curve. We're going to interpolate the starts and we're going to interpolate the ends. We show again the curve connection part. Not sure what you mean. Created curve ends, created endpoints, and interpolated. That's all I did. Okay. So now I'm just going to say that's another group. In this group here, we basically like rebuilt the edges there, right? So now we have this. Turn this on for a second. This one. All right, so now you have this like something like this. Okay. Just group that. Okay. Save. Okay. So next thing we want to do is we want to make kind of regions from these closed areas here. And in order to do that, we're going to use a nice plugin, which is called Polyline Offset, which is from Clipper, which is also another plugin, Clipper, that it says to install. And so that's called Polyline Offset. Curves are planar now. So I'm just going to get a curve parameter. Curve. Just to make things a little easier for me, I'm just going to, not that one, I want this one. I want the extend curve. And I want these two interpolate curves. So let me just move that down and out of the way there. And hold shift and drag those in. So we plug all that in. And so now we have the cross curves and these curves coming down. We have them in the same parameter here. And then we're going to plug that into Clipper. And we need to give Clipper a distance. And we don't want this outside boundary, we just want like the inside stuff. And that's from this H here, which is called holes, basic holes polyline, and then contour polyline. We just want the holes. So I'm just going to use a data param, whatever. So if I hide this curve here, basically what that's doing is it's giving us like the regions, basically, you see. So as I do this, it's doing that, right? So it's giving us kind of the boundary regions of those that those curves made, which is what we want. And give them some space like that is fine. Do we get the requirements from somewhere? Because I missed the first part of the steps. Yeah, I'm not sure how else to. If you signed up for this, it was written at least in 5 different places if you're getting the recording or not. So check the website or Instagram post or the Zoom form. Yeah, I mean, as funny as it sounds, I mean, I would say 90% of questions from students in these cases is just from that kind of reading the information of the thing you're signing up for. But yeah, the information is always there. We're not hiding information from you. We want you to have this recording and learning just so you can learn it. We know it's not easy right away. So we're going to get reduce. And that's just going to make the polyline like less. We're going to give it a tolerance, and that's just going to make it like less sharp. Right? So more rounded. So as you see, when I do that, right? Because this is actually making a polyline from the curves, but it's a very dense polyline to be able to make that curvature. And we don't need all that density. So we're just going to reduce it, and it'll be a bit more jagged. Something, you see how it's something like that. We can do something like that. It's fine. Not showing up. Polyline offset is part of Clipper, as mentioned. It's Clipper plugin. Download Clipper. How to delete border and I didn't delete anything. I just unpreviewed stuff. Just click preview off or preview on, whatever you want to have preview off or on with right click and preview off, preview on. No, data does not do any function. It's just a container. Just so I can see this instead of seeing it with this output too. Okay, so we reduce the polyline, and then we're going to use a Pufferfish component called polyline to mesh. And that's going to turn all those into a mesh, right? So now we have these kind of like mesh islands. Right. And you can see the mesh gets more dense as we change those polylines. Does that work? Only on planar curves. I think so. There's a plane input, so I would assume so. But we're only using planar curves anyway, so okay. Okay, so that's another kind of chunk of stuff there. Okay, curve shows error, insufficient insertion points, no matter how many curves I use. You shouldn't be using curves for interpolate, you should be using points and points. And again, I'll save. I'm saving all the time, so if you fall behind, just download it from the Dropbox at current state if you want. Okay. So next thing we want to do is we want to like remove small stuff like this kind of weird thing that happened there, like that. So we want to remove any kind of islands you might have, like small islands. To do that, we're just going to get area. Just going to measure the area, and we're going to say if it's larger than some number. So I'm going to say it's the R area is larger than something, basically remove it. Okay. So then call pattern. And we're going, so basically with call pattern, we're going to take these and we're going to call them based on this pattern, this true false pattern that's saying if the area is larger than this number. And turn all that on, preview all that. So you'll see if I do that, see that in this case, I only have like this one island that's kind of small. So if I just do that, like you'll see it gets rid of that. If I went even higher at some point, it would start to get rid of like some bigger islands too, like you see over there, but we don't want to get rid of those. So you just play with it until you get rid of basically the small islands that you want to get rid of, which in my case was that one down there. Okay. Just organize a bit. Okay, that's kind of like another chunk there. And like, can you explain how tolerance for the reduced control points curve works? Sure. So it's just basically the allowed deviation. So if you read it, it's the allowed deviation between original and the reduced. So it's basically going to try to reduce it as much as possible. Like here, it's going to try to reduce it as much as possible, but we're saying it has to stick to this tolerance. So if I put this tolerance way up, we're saying it's allowed to deviate. Deviation means how far away from this curve it is. It's allowed to reduce as much as possible, and it's allowed to deviate 1 unit, in this case millimeters. Where if we go here, you see we're saying if we say 0, it's just going to give us the exact same thing. We're saying it's not allowed to deviate at all. Here, whatever. If we do like 2.85, it's allowed to deviate. So it's saying simplify this curve, and you're allowed to deviate only as much as 0.285. That's basically what it's doing. That shows all instead of the way yours are. Mine are all in XY plane. Minus like that. I'm not sure what that means. Maybe you can clarify. So yeah, so the next step is we want to make sure that the normals are all facing inside the created meshes. Oh, sure. So if you want to turn on and off the preview mesh lines, you just go to display preview mesh edges, or you can press Control M. So Control M, it will turn that display on and off. Sometimes I have it on, sometimes off, depends how dense the mesh is and what I'm trying to do. If it's like super dense mesh, it gets hard to see when you have them on. But yeah, Control M or display preview mesh edges. So now we got to make sure the normals are correct. And what I mean by that is if I bake this, so I just like middle mouse and click that egg, and I'm just going to drag it over. And I'm going to go to shaded. Sure. Save. Now you'll notice I have two different colors here. The way I did that is if you just go here to properties, actually display. So display object settings. There's like this color back faces. I always have that on, and I always have it like a really abrupt color like red. So you can change the color there. That'll let you know like what's the front face and what's the back face of your geometry, and you'll see that they're mismatched, right? That's just because it's based on like the winding direction, and Clipper doesn't always keep the same winding direction because it's doing a pretty brute force operation there. So what we want to do is get those all in the same direction. Otherwise, we're going to get issues in our kind of next steps where we kind of thicken this. So let's do that. So in order to do that, by the way, if you ever get like lost, like over here in Rhino, you can middle mouse on the component and click this magnifying glass, and it'll like bring you to that geometry. Right. Okay. So let's get the face normals. And that's just basically going to give us a center point, which we're not using. But the important thing is going to give us the normal direction, which is the direction, basically front face direction is going to be, in this case, either up or down. And we can see that if I come here to the panel, you see like -1. That's X, Y, Z. The normal is upside down here, right? It's negative here. And then in this other mesh, it's positive. So we want to make sure they're all positive, let's say. So we're going to do deconstruct. And we're going to deconstruct. And we're going to get only the Z values. So now I have just those Z values, -1, +1, -1, because we don't care about the X and Y. And we're just going to do a list item because we know that each mesh island, like at least the faces within the island have the same. So we just need one of those per island. And if I look here, right, so we just have, now we have basically one normal direction representing each mesh face, either a negative or a positive. Okay. So now we're going to test equality, which, second. Yeah, so we'll just test equality. Test the equality of this. And we're going to say, does it equal -1? And we're just going to flatten this output. So now we just have one list of, actually, maybe it's even more clear if I flatten it here. So you can see the kind of correlation between, right? So we're saying, does it equal -1? You see there, -1, true, 1, false, 1, false. So if it's equal to -1, it's true. Okay. So what we want to do is called a sift pattern. Take this pattern, and we're going to sift the islands, right? So let me explain that. So what sifting does is it puts each thing it basically splits up the list based on a Boolean, which we have here, into a 0, 1 output. But it's a bit different than, say, for instance, dispatch, which has same inputs, right? But dispatch, yeah, I'm constantly saving it. I mean, just saved it like literally half a second. So I'm always, even if you don't see it on my screen, I use Control S, so that's why probably you're not seeing that I'm saving it, but I'm saving like every few seconds. I just do that to habitually anyway. So the difference here is that they're giving us the same thing, except for I think that weirdly sift and dispatch are kind of like opposite. So that's just like a stupid Grasshopper thing. Like they should have made those the same. But what's happening here is here we have basically those ones that were upside down. And you can see them like that. Now here we have those same ones that were upside down. Oops. But instead of destroying the list, which here we destroy the list, right? We have 3 meshes that are upside down, but we want a list that has the 3 meshes upside down. We want to keep them in the original list order. So what it does is just fills them with nulls. So you have the same length of list. And that's really nice because now in sift list, the other end, which is the ones that were the correct direction, is going to be the complete opposite of that. And now I can do is I can flip these and then just combine these 2 lists. And like, you know, because they kept the length and the nulls are opposite, it will just combine it all back together into a list for us again. Okay. It is updating in Dropbox. Oh, maybe I saved it to the desktop on accident. Maybe. Let me check this one. Yeah, good call. Okay. Somehow I switched it to. Somehow I switched it to. Let me just put it. Just override the Dropbox one real quick and get it set there. And then, one moment. And okay, should be good now. I don't know how that happened, but it did happen. But it's fixed now. If I get all the line false, what does that mean? Inequality. If they're all false, that just you should still do this, but it just means that in your case, and that could happen totally. It just means that in your case, they all happen to be in the same direction, which is fine. This is like a kind of you won't always have the same situation. You might have them all upside down, all forward, or some up and some down. But either way, do this because what we're doing now will fix it. If it's correct, it won't change it. If it's wrong, it will fix it. So that's why we want to do it. Let's look again. Yeah, here. That's okay. Yep. So what we're going to do now is we're going to basically, again, data doesn't do anything. It's just so that I can see, you know, what's selected. And we're just going to flip those ones. So we have to flip. So again, if you're empty here, it's okay. Just let it be empty. But we just want to use it as a just in case something goes the wrong way, or if you're empty here, it's just in case. And in my case, you can see it is they were incorrect. Right? So we're going to flip the mesh. Just plug it into flip mesh, and now because we kept those data structures with the sift pattern, and so we have opposite nulls, we can just take these ones and these ones, and it combines them back together into a list with the combined data components. Combined data looks for nulls that are opposite between input lists and then fills everything in on its own. So now we have that there. So now if I bake this, and just bring this off to the side. Now you'll see I have everything in the same direction, and the front faces are facing upwards. Okay. So that's kind of another chunk there. So the next thing we're going to do is we're going to create thickness, but we don't want just like a uniform thickness. We want a kind of more thicker in the middle, thinner towards the edges, so we get like this more kind of pod, bulb kind of shapes. Combine data and merge. Merge just literally forces things together. Like if I merge this like this, merge is very literal. So you see all the nulls are, it's just like taking the two lists and stacking them basically. Where combined data is looking at the nulls in each list. And so if I go here, here, right? And then that's the result, right? So it's saying, okay, compare 0 and 0, there's a null, fill it in. Compare these, there's a null, fill it in. It's just basically like, imagine just filling in all the nulls with the information from the other list. So now you have this list here. Just rebuild mesh. Yeah, so rebuild mesh doesn't really work here so well because they're not connected. So you could use like rebuild to like unify normals. But unified normal isn't really trustworthy when the meshes aren't actually, I mean, you can join this, it can join to one mesh and be read as one object, but they don't physically touch. So unifying normals doesn't work really always so well if the vertices aren't touching, because it doesn't really understand that this should correspond with this. So you have to kind of just do that manually. I tried to replace lists longer, but work. Yeah, I mean, there's many ways to do things if you want. I like the sift combine combo, but yeah, you can also replace lists too. Replace lists is a more, it's like old school way. Ever since sift pattern came out, sift and combine came out, I never went back. I just always use sift combine. So, but yeah, you can totally use replace normal. So replace normal, replace this. Replace list is like the original kind of way to do this stuff. So now we want to create like a bulge, kind of pods from these. So we don't want to just do something like, for instance, like offsets. We don't want to do offset mesh. I don't even remember. This is my component. I don't even remember what I named that. Offset mesh, or from Weaverbird, thicken. Like we don't want to use those because Weaverbird does let you do it by vertice, but it's just in one direction. And offset mesh is kind of one solid unit. So we're going to construct something that's kind of like a edge-based offset, let's say. So first thing we're going to do is we are now going to join all these meshes. Now, join in meshes, join means something different than NURBS. It just means that it reads as one mesh object, right? So now, and that's similar in Maya and Houdini and everything else. Like when you join meshes, they don't have to actually touch. So you see it's just one mesh now, even though there are separate parts. So we're going to join that mesh, and we're going to use a Cathmol Clark, which is from Weaverbird. If you have installed Weaverbird, please install Weaverbird. And we're going to give it some subdivisions like that, right? So because we want more vertices, but also we want like a rounder kind of object. So now we're going to get something that kind of like round like that. And what we're going to do then is we're going to get the naked edges. Thank you, Abraham, for putting the link there. Weaverbird, when you install it, actually, so Weaverbird, I'm just gonna open it. So when you install it, it installs a bit differently. So Weaverbird, you just download this, and it gives you a Grasshopper, a .gh file, and basically you just open that file. And if you don't have Weaverbird installed, it will like bring up a prompt that will walk you through the steps to installing Weaverbird. Okay, it's a little bit different there. So you just download it, take that GH file, and just drag it into Grasshopper, or just open it with Grasshopper, and it'll walk you through the steps. Okay, so now we're gonna get the edges. So now you see we're taking the naked edges there, and we're gonna also deconstruct mesh so that we can get the vertices. Okay, so you have now the edge and you have all the vertices. And what we want to do is we want to measure the distance between these vertices to like their closest edge. And luckily we have a component that figures that out for us, which is called pull point. And it's default set the closest, which we want, closest, which will say, okay, what's the distance from each point to the closest object? In this case, it's going to be the edge curves we're going to use. So we're going to plug those edge curves, which is here, which is the N output, into geometry. And then the point to search from is going to be our mesh vertices. And it's just going to give us a bunch of distances now, right? Based on that information. Now we want to use a graph mapper for this. Well, we want to enable the use of a graph mapper for this. So what we want to do, why do you use reduce first and now use Catmull-Clark to make the edges soft? Well, the Catmull-Clark inadvertently makes the edges soft, which is nice, but we're really using the Catmull-Clark to subdivide the mesh into more points. That's the reason why. If I don't reduce, the Catmull-Clark is going to be crazy dense, because the initial mesh that it's subdividing is going to be denser if I don't reduce. For instance, if you look here, if I increase this, decrease it, it's going to be the mesh that's going to be being made. It's like, you see, it's more dense, like in this kind of areas here, which I don't want. And also the kind of the shape is sharper, which I don't really want. So that's why we do that. Because Catmull-Clark is just subdividing. Right? So if you start with a denser mesh, you're going to obviously subdivide more stuff and have a denser thing. So now we need these distances. Yeah, this one's part of Pufferfish. I think Weaverbird has one also. I just use my own though. Mesh naked edges, part of Pufferfish. So we need these distances. We need to make sure they're between 0 and 1. And we have a component in Pufferfish which does that automatically, reparameterize numbers. Just plug the numbers in there and it'll automatically adjust them to be, equally between 0 and 1, which is what we want. And then we're going to use a graph mapper again, like before. And graph mappers, like the inputs are 0, 1, 0, 1. You could change those, but then it becomes not really parametric, so you have to change it every time this distance changes. That's why you go 0 to 1. So no matter what this distances are, it'll always work without breaking. And then, so that's just so that we can give it we can just give it some curve if we want. But then what we really want to do is then remap numbers. And so we'll remap those values. The source 0 to 1, we already are in 0 to 1, so we don't have to change that, but we want to change the target. So what we're going to do, struct domain. And put that here. That's going to be the target. And so we're given two numbers, and those two numbers are going to represent what we're mapping these numbers in between. And that's going to basically be like our minimum and maximum offset of vertices, if you will. So just get a slider. And this can be something small, and this will make sense in a second once we actually do something with these numbers. So if I actually use this component from me, this from Pufferfish displace mesh, and we get the mesh we want to displace, which is the catwalk card. So let me just move this up, bring this here. So that's the mesh we want to displace. And it's saying the distance for each vertice, which we got here, right? Because we're measuring from vertices to edges. So if I did like that, right, what's going to happen is you're getting these kind of mountains, right? Which are tighter at the edges. So actually, let me turn that on. And so now what's happening is this number here is controlling like that edge condition of each one. So like what's the edge there? And then this number here is controlling like the kind of bulging. And if you wanted, you can do like this can control like the kind of fall off if you wanted to create a different kind of shape there. Right. It's okay if it's sharp like that for now, because it'll be changed like when we go in Houdini and all that. So you know, you can just adjust that, maybe a bit like more bulged. That, give it a bit of, you know, thickness on the side here, which is from like this. Something like that. But what we really want is we want to do that on both sides and then connect between those. So what we're going to do is we're going to get the negative numbers so that we go in the negative direction. So negative. So I have negative, and what we want to do, just turn that. I just disabled that for a second. Is we want to graph this, and we want to do a component called entwine, and I'll explain this in a minute once I turn this on. And we want the positive numbers in 0 and the negative numbers in 1. And we'll plug that into the, so, and then let me enable this. Okay, so what did I do there? So basically what I did was I took I have the meshes. I have the meshes and I grafted them. Grafting them, you know, if you look at graft, actually this is not showing here. I guess I don't need to graph there actually. Sorry, you don't need to graph there. That's just my mistake. So you have this one mesh, and what you want to do is two different things to it. So we want to do the positive upward and a negative downward. So we use entwine. And what entwine does is it gives them easier to see probably with a tree here. So that has two branches, right? This branch is all the positive and that's all the negative. So it's going to say, with that mesh, do all this stuff, positive stuff, and then do all the negative stuff. And so then you'll get output to meshes in the same, you know, structure. Right? So now we have the positive and negative meshes. You can use instead of Weaverbird's component. I've tried this so many times and couldn't, I guess, related with my Rhino version. Not really. Or at least not that I, maybe there is, I don't know. I always just use Weaverbird for subdivision stuff. But I don't know why it would matter with your Rhino version, because Weaverbird has probably the first plugin ever made and has worked for every single Rhino version. So not really sure. Can you guys please save the Dropbox link somewhere? Maybe save it in your notes, or so if you leave or whatever, you can have it. There'll be a few breaks. I don't have displaced mesh means you don't have Pufferfish installed. The Pufferfish, we're using Pufferfish 3. And we always use the newest. So okay, that's another chunk there. So yeah, I mean, speaking of breaks, let's take a small, I don't know, what do you think, 5-minute break? Does that work for everyone? Try to, so you can try to catch up. Entwine is not mirroring anything. We're mirroring like negative and positive. All Entwine does, Entwine is a data component. All it does is set each item into its own branch, each input into its own branch. So now branch 0 is going to be all the positive values, and branch 1, 0, 1 is going to be all the negative values. It has nothing to do with mirroring. The mirroring is happening because we're remapping and all, so we're using positive values and negative values and doing two operations, positive, negative on a mesh. If you have pufferfish and don't have displace, means you have the wrong pufferfish or an old pufferfish. Use Pufferfish 3.0. Okay, so I've saved both. Save. I'll try to. Not really a great way to do this. Try to at least capture this end part here on the screen. And so yeah, well, let's come back in like 5 minutes. Okay, we're back. Yeah, I mean, to delete the plugin, it's very easy. You just go to the same folder, just click it, whatever, and then just delete it. That's it. Okay, so we're back. Back in action here. Okay, so let me just. Okay, so next thing we need to do is we need to make the connection between these kind of bulbs here. And so what we're going to do is we're going to get the naked edges again. Naked edges. Okay, so now you see the edges are highlighted, naked edges. And they're in, if you look here, they're in 10 and 10. They're two lists of 10, so they're going across ways, like 10 and 10. But we want the lists to be like pairs of 2. And Grasshopper gives us an easy way to do that, which is basically just called flip matrix, which basically just flips the data, right? So now we have 2, 2. So if anyone doesn't really understand that, just a brief understanding is basically what we did was we took the 2 and we said instead make that per thing, right? So we have the 2s, and we took the 10 and we made 10. So imagine you have a list of things, and they're grouped like this. All flip matrix is doing is saying instead of grouping it like that, flip it and group it. Like this. That's all that flip matrix is doing. So now we're going to loft those together with a mesh loft, and we can use from Pufferfish, which is called a parameter mesh loft. And it's asking us for the section curves, so we want to use these section curves. But you'll notice that they don't really, they kind of come off like there, like in places. That's because by default, it's just using UV parameters, which is more like divisions along those edges. But there's a input in Pufferfish where we can force it to say, okay, use the divisions of the section polyline. And that's just a Boolean. And it's this one here, length, L, length. So it says, if true section curve mesh face divisions are defined by the lengths between the control points instead of the U parameter. This is the U parameter, right? So if I actually came here and changed this U division, you'll see what happens there is it's actually like the number of divisions around that edge, but we want to override that. So we can override that by just making L and true. And now you see it's snapped, and now it's following exactly the edge conditions. And you got this kind of like nice band around there connecting. Why did we directly lofted mesh? Why didn't we directly lofted the mesh naked edge? You can't, because you do this. That's what I just explained. If you want, you can relook at the we look at the recording later, I just explained it, what it does. It's just instead of grouping it crossways like it is, we're grouping it by flipping the matrix. So definitely check out I don't want to explain it over and over and over again. Just check out the recording when you get a chance. So yeah, so now that we did that, we want the V is going to control the divisions up and down. I mean, it looks pretty good right now. I try to make it kind of like similar in size to like what's happening above. It's pretty close now, but we can change it. Maybe I'll do. I think it's 4 there. I'll just do 3 for instance. You can see that that's changing that divisions there. Something like that. And kind of last step of this sequence is to the last step to this sequence here is basically to weld this all together with the top parts. So we're going to get a join mesh. We're going to flatten the input just to make sure that everything comes together. And we're going to give it the results from the entwine. There's one more thing I need to do that I left out. So the other thing is this, because we're just displacing up and down, what's happening is if I bake that displace mesh, because this mesh that we started with, if I go to before the displace, which was the mesh before this one here. Let me just get that real quick. So you see how it's, we got the positives up, negatives down, but now if I'm moving these up and down, what's going to happen is, they're going to be in the same direction. What we really want, if I just type flip, is we want that because we want to create an enclosed thing where like naked stuff, the back faces are all inside. So we just need to flip that bottom first, which I forgot. Sometimes I forget things. So the easiest way to do that is we can just do explode tree. And that's just going to put them in their own outputs. So if I just get data so you can see, now we have like, that's the bottom and that's the top. And we're just going to flip the bottom one, flip mesh. And then we just bring it back together, entwine again. So we only exploded it out just so that we can just flip just one of them. We don't want to flip both of them. So that's just to flip that bottom, and then we're just going to plug that in there. And what that does now is if I bake this and bake this, you should have everything kind of gray outside, and then like so all the back faces are on the inside there. right. So now we're going to join these, which is the mounds, top and down mounds with that band. So shift and drag, and then they're all together there. But again, remember, join just makes it read as one mesh. We want to actually physically weld this together so that the vertices where they meet here aren't duplicate. And we can do that with Pufferfish's rebuild mesh. And rebuild mesh has a bunch of useful operations. For instance, recalculating the normals, removing unused vertices and faces, unifying normals, even though we've kind of like force unified them, but still do it anyway. And then combining identical vertices, so those vertices that are identical. And the last thing I always do is the bottom, which is a weld, which is a nice one because sometimes these vertices you don't even notice, but in tolerance, I don't know why you guys are using raise hand. Don't use raise hand because I'm not doing anything with raise hand. If you have a question, just ask the question. And then so yeah, so those vertices, like it looks correct, but there are instances where it could be like 0.0001 off, and this combined identical only combines them if they're exactly on top of each other. So what weld does is lets you set a tolerance, like a kind of secondary tolerance, just to capture those situations. So let's say if anything is within this tolerance to also weld it. It might not be in this case, but we're going to do it anyway, just as a kind of safety. And we can tell that worked because if I go here and I go here, you can see the vertex count V changed significantly. That's just because all those edges where like the wrapped around part meets the mounds, instead of there being duplicate vertices, like one vertex for the wraparound mesh and one vertex for this top one, now they're actually combined into one vertex. So now we've got basically an actually joined mesh. Right, so if I bake this, and sometimes you get some like some weird stuff like that. I don't know why that happened, but let me see. It might be that because we're like kind of double unifying, so let me check. Yeah, that's why. So in this case, don't use unify because we've already unified, so it might like throw it off. So now it's good. So you should have something like that. Right, and these are actually like solid meshes. If I press like point, if I type points on or press F10, you can see that in this edge here, that's just one vertex. There's not multiple vertices. Okay. So let's backtrack a little bit because now we need to make what I was calling the kind of roots. And the kind of also the cross roots as well. So the cross ones are pretty simple. What we're going to do is we're going to go all the way back to this this first extend curve here. That was these ones here. Okay. And also keep in mind, like the cool thing about this yeah, the rebuild mesh also usually, this rebuild mesh here usually fixes like when you have, what do you call it? I can't, the name is escaping me, but a mesh that's not, you can't bake. I don't remember. There you go. I couldn't think of that. Yeah, invalid mesh. So if you ever have an invalid mesh, usually Pufferfish's rebuild mesh can fix that, which is kind of nice. So the cool thing about this process is we can be pretty messy because a lot of it will be
fixed in Houdini just because of we'll be using these kind of VDBs. Which is kind of nice. So now I'm just gonna get a curve parameter, and I'm just gonna apply this here. Again, curve parameter, these parameters, anything from this like params, geometry, and primitive, they don't do anything except for hold data. Right? So we're not doing anything. It's just a nice way to bring that data somewhere else without the wires getting like too messy. And you can also like double click wires and do like stuff like that with the relay, but I like just to use the parameter. So we're gonna get the parameter mesh height, parameter height mesh, and those curves are going to be what we're going to pipe. So you see it made some pipes there. We need a radius. Just going to control the radius. In this case, we're just going to use a single radius. We don't need a variable radius for these. And we're going to control A, which is the angle. So what angle, so there, if you remember, there was the length input, right? So there was this Boolean toggle for length. And so that's just gonna use like the kind of polyline version of that, which we used, if you remember, we used that over here somewhere when we were doing the lofting, right? It's the same options. And also loft has this A option we'll look at now. Now the other override you can do is instead of length, you can do it by angle. And what that means is it's basically going along that curve and it's looking at like this as the maximum angle. So if I reduce this, let me just turn this off for now so you can see things. So now see how it's like divided more here because it's more curvature here, but then like here it's less curvature, so it's like less divide. So angle is just basically following, it's just like traveling along the curve, looking at angles and then dividing the mesh based on like the angle that you input, like the maximum angle. Okay. There's angle accuracy. And we want to just we want to cap the ends. So we have end types here. I was just using flats just because they're easier. But you could use other, but we don't. It's not really necessary to use anything else. So you can get like a round cap, but they're gonna like blend into something else. So we can just do a flat end cap there. Okay, so that's like the kind of cross connections, and that's really all we need to do for the cross connections. Now we want to make the ones that go with these curves here, and for those we're going to use a variable kind of condition so that we can like get thinner maybe at the top and thicker maybe at the end there. Sorry, thicker in the middle. So first thing I want to do here is, again, I want to get a curve and I want to plug these in so the two interpolates so that we have both those edges together in one thing. And I want to do an extend. This is just for like stylizing. So we get extend curve, and the extension type we're going to use is arc type. So let me maybe just
that. Yeah, and so then we'll get two different values for the ends and starts. Let's just get two different ones. So you see how it like kind of like it basically extends it, and this is just to give it like a little bit of stylization. Like I was doing like something like this. This is cool. Like at the end, at that end, and then like at this end, maybe do like a I don't know, just like a little extension. So I kind of like that overlap. I think this kind of cool. So let's yeah, let's roll with that. And so now what we're going to do is we're going to work through creating this this variable thickness type, if you will. So 1 second. Yeah. So we're going to get the length. And measure that. So that's just going to measure the length of those two curves. And we're going to do division. Division. And just get a slider here. And so we're basically dividing the length by some number, which is going to give us our division count based on like we want to try to get like we're saying in this case like try to be every 5 units, like divided equally, but try to be something like this. So we're going to use per frames. Okay, so you'll see if I change this, like if I have less, it's going to be much more dense. If I have more, it's going to be more. The reason we do that instead of just putting a number here is because these curves aren't the same length, so but we want them to have like kind of the same distribution. So they're not going to have the same amount of division. So you can see in this case, one has 20 and one has 22. So that's why you don't use divide curve, because we want to think about the density, not the number. So in this case, one has 11, one has 12. They're pretty close to the same size in this condition, but if I were to, for some reason, I'll Control Z. If I were to like shrink that one or something, you might get, yeah, it's now 16 and 18. So that's why you do that instead of divide curve. So it's just gonna divide up. So again, we're dividing based on like kind of approximate distance rather than actual number to get the per frames. Now what we want to do is we want to put a polygon at each frame. So we're going to get a polygon. And by plugging the frame into the P input, we've oriented the polygons to each one of those frames. And we need to play with the radius, right? We want like a variable scaling radius. So I'm going to use this divisions to give me a range. And like n and n, they're going to give me the same result, which is nice because they're both rounding the same way. So 25, 27, and here 25, 27. because they're rounding this number the same way the inputs there. But in this case, I did that because I want numbers from 0 to 1. You know, so 0 to 1 based on that. So, if we get a graph mapper, now in this case, we're not using a tractor for distance. We're actually just saying from start to end. So 0 at the start, 1 at the end, and we could change that with a graph mapper instead of an attractor. So if I just go to, again, Benzier and we're going to remap. We need to remap the numbers because we want to use radiuses, right? We don't. Our radius is probably likely not going to be 0 to 1. So like that, and source is already 0, 1, and we just get construct domain. Just get 2 number sliders. So we're just setting the minimum and maximum radius basically. And then we're just gonna plug that in. And I'm gonna make the mesh first, just so that we can see what's happening. So we're gonna get again, we're gonna get like what we used before, the parameter loft mesh. Use those section curves, but again, we want to snap it from polygon to polygon. Or sorry, like we want to snap it to being around the polygon, like you see how it's off on the polygon there. So that's again that length option. So just turn it true, and you see now it's now the divisions around are going to follow whatever you set here in your segments. So let's just get something there for segments. So now whenever I set this, you see that it's following that now because of this. Where if I did this, it's not going to really, it's going to change, but the amount isn't going to change. We're not going to stick exactly to those polygons there. Okay. So what we can do now is, if they're both at 2.25, if I make one smaller and one bigger, what's happening is, in this case, because the list is directly from 0 to 1, we're getting smaller here and bigger at the end, but maybe we want bigger in the middle. All you got to do is just like mess with this graph. You can do something like this, for instance, and now you have like smaller at 2 ends and bigger in the middle area. That makes sense. Okay, so you can make that as, and actually, if you make this bigger number if you want. Totally up to like whatever you want. This is kind of like design stuff, so you can do whatever you want there. And so like now what you have is you have this and this is kind of like your, let's call it like your branches or something. And it's okay, like if they're all intersect, whatever, it doesn't matter. That'll all be covered in Houdini. What do you use for source? Source right now is nothing because it's already set to 0 and 1. And we're outputting 0, 1, so we don't need to change anything. The default is fine for that. And then V, what we want to do for V is we want to make one division across each polygon. So for V, it's instead of doing 0 to 1 with a range, when you want just one of something in Pufferfish, like parameters, you can just actually put 1. So now you see we have one division between each polygon. So if I turn on these polygons, you see there's a one span between each, versus like if you change this B domain or something. So I have something like that, and you have something like this. So that's all good. And again, like you can be messy, you can play with the settings to like try to get cleaner. I mean, it really doesn't matter, and it's all changeable, and the results are pretty interesting. So when we get there with the Houdini part. So the last, yeah. So now with Grasshopper, what we need to do first thing is just so we can coordinate easily with Houdini. What I like to do for revisiting, check the websites. Information is there. So just to coordinate with Houdini a bit better, I'm just going to move all of this, like kind of just try to associate something with the origin. And in that case, what I'm going to do is I'm going to get the endpoints. And we're going to get the endpoints of our kind of extended curve here. I'm building this over here because we also have to do something with this as well. So that's why I'm doing that. You can also just bring it over, like it's easier to understand. Just bring this like this, and this like this. Okay, so that's the endpoints of those extended curves there. And we're going to average the start points. Like that. So that's basically taking the two start points and averaging them to get like a kind of center point between them, let's say. And what we also want to do is we want to join these two together to be one, just to read as one mesh object. So we'll join. We'll join the pipe with the, and I will flatten it just to make sure they all are in the same list. And I'll preview all that because now I just want to preview this one. Our kind of result there. Okay. And we're going to move it. So in Pufferfish, we have this move to point. And the geometry we want to move is this. And we want to move it from the average here. So let me actually bring all this way over here. Again, I'm just doing it because I'm gonna have to do the same with this, and I kind of do it together. Um, so we're gonna move from the average point. We're gonna move that geometry from the average point, which we made here, to the origin. If you want to get the origin, you can just type 0, 0, 0. And so now we've kind of associated the center of those two endpoints with the origin. So just turn it off, and then so we obviously got to do the same to these like bulbs so that they move as well. So we'll just get another move point, and we're going to use the same. We're going to use the same thing, the same association of that average point and the same 0. We're just going to move now these bulbs in the same way. And the reason I do them separately is because at this point we need to split them into 2 different things for our Houdini, for the outputs we're going to make for Houdini. So I just chose that this was a good point to kind of split off into 2 separate things. But you could also, you know, I mean, I guess we could actually, let's see, maybe it's cleaner, maybe if I just shift and do that, I can just do them both together. It's fine as well. Less components, curves that I'm seeing there. So that's the moving. And I also want to give it a kind of override for scaling. So I'm going to get a scale NU, which is a non-uniform scale. Put those in there. Geometries, and the point to scale from is going to be our origin. And then you can control like kind of scale if you want to scale X, Y, and Z. We can also do this kind of stuff in Houdini as well. I'm just gonna control maybe like an override of the X direction if we want it. Just a little override if we want to scale it here, or we can just leave it as is. Up to you. The option is there, and if you wanted to scale in any other direction, you can just do it as well. If you wanted to scale in Y or scale in Z direction. I'll just leave them for now. And then let's give this thing maybe a little bit of a like an option to be able to twist, maybe like a little bit of a twist option. So we'll get this twist, this native Grasshopper component, geometry to twist, and we need an axis. We need a twist axis. So all we're going to do is we're just going to create a line STL, which is line start direction length. And we'll make a line starting from the origin. And direction will be Y. So that, if you see down here, Rhino Y direction, we want to twist, like the twist axis should be, in this case, along the length there. So we twist it like along that axis, or we twist around that axis, basically. And length, just start with some number until we see it and fine tune it. Okay, so that's going to be our just there. And then we'll get a the last piece is we need an angle, and it wants it in radians. So we just get a radians component, and so we can use degrees, and it will convert it to radians for us. And degrees are 360. It could be at any number you want. That, and then so 360 would be pointless. And that's the end here. So if I go here, just get a mesh, right? Just turn this off, and then so we can play with this now. If we wanted to do something, we can have like less. Maybe we want it to just twist a bit, something like that. Really up to you. Maybe we'll just add a slight twist. And you can also enable this to, let's see, so you can go minimum to negative. So if you go the other direction, we'll go the way you want to. And okay, so now you have that. And so the last part is we need to split this up so that we can send them to Houdini separately. Since we did it all together there, all we have to do here is actually we can just dispatch, should be fine. Yeah, so there's your two things there. So we dispatch them. All right, so the next stuff is we'll be getting it to Houdini. So I think maybe it's time for another good time for another 5-minute break, since it's the end of the Grasshopper building. I mean, we'll adjust parameters as we go, but that's basically the end of this this definition. So I'll save it, and if you don't have, get it. And also in that time, if you don't, we're going to need HouGh now. So make sure you have that. It's on Food for Rhino. Which you should have already. Right? Let's see if you have Food for Rhino. This one here. Should have installed it previous, but if you didn't, now would be a good time. And it comes with a PDF, and there's two things you need to install. There's a Python part and just follow the instructions. It's super easy. It's like 2 steps. It's pretty clear, but it's not just dropping like the GHA. And so, I don't know. I don't know if it works on Mac. I don't use a Mac. I mean, it says here Windows, but just because it doesn't say Mac doesn't necessarily mean it doesn't work on Mac. So that I can't say. Try it, see if it works. And you'll be wanting to use always the latest. In this case, is 0.13. Not there for Mac. Oh, well, I guess you'll just have to export manually if you're using a Mac. I don't really use. I mean, I don't personally suggest Macs ever for computational design. There's just too many things like JSON and all this stuff. Too many things that don't really work with Mac so well. But have you tried this HouGH 13 and tried to install it? You can't install that for Mac. I don't know. Again, just because it doesn't say Mac doesn't mean it doesn't work for Mac. A lot of things they just forget to check Mac, or they just didn't test it on Mac, but doesn't mean it doesn't work for Mac. There's plenty of plugins that work fine for Mac, that just the author doesn't list it or forgets to list it or just didn't test it on Mac, so they don't even know themselves. But I feel like it probably works for Mac. I don't see why it wouldn't. I don't see any complaints about no Mac here, so usually you'll see like no Mac version or something in the things here. So it should work. I think it will work. So try it out while we take this break. Okay. See you all back in 5. This B from this stage. Well, that's something with your data structure then. Somewhere you probably missed maybe it's a flat in here or something. So just download the file, compare it with yours if you want, and see what's different. Okay, see you. Okay, I'm back. Can anyone confirm that it works for Mac or not? The HouGh plugin. No, no one knows. Okay. So also just want to remind you, feel free to take screenshots and post them to your stories and tag us. We'll reshare it. And you can tag me as well. I'll just put the Instagrams there. And also for those that joined later, the files that I'm working in live are here. I save them as I'm going. Where to paste? Yeah, just check the document. That's the thing, like with very rarely is there a question unanswered by the documentation. So you just have to take a look at it. Just get this thing. Okay. Yeah, so when you download it, just right click. First thing to do, right click properties, unblock, and then extract whatever kind of unzipper you're using. Once you have it, there's always documentation. So here, it's literally the first page, copy HouGh to program files. In this case, Rhino 7, plugins, Iron Python, whatever. And then you copy the user objects into the user objects folder. Right? So again, so user objects, these are user objects because they're Python. So those user objects go into special folders, user objects, and then there's the HouGh user objects folder that they said to put there. And then Python is, where is it saying to go? It's saying to go to program files. So I'll just go to my C drive and go to program files. And then I don't know how this is in Mac. In this case, Rhino 7, and then plugins, and then Iron Python, and you just drop it into lib lib. That Python file, just drop it in here. What's it even called? It's called HouGh, so I'll have it already in here. So yeah, always read the documentation because they always tell you exactly what to do. Same with Pufferfish; that's exactly where to put things. Okay, so HouGh. So basically, we're going to create a link to Houdini using JSON files. And the way that we do that is there's a lot of things you can do with HouGh and bringing different kinds of information data, but we're going to use it in the simplest way here, which is directly bringing a mesh, linking it into Houdini, and vice versa. So all we need is here we go to define H object, so define a Houdini object, and primitives. So primitives can be meshes, polylines and NURBS curves. So we have a mesh. And we do the same here. And then what we need to do, so now we've defined it as a Houdini object. So basically what this component is doing is it's reinterpreting this mesh as the kind of mesh data that Houdini understands. And that's all that's doing. If you click into it, you can actually see the Python because it's a Python script. If you're interested in looking at that. But you'll notice that the output is not anything we can view, right? Because we're just creating data. Let's get a. Right. This is not any kind of data that Grasshopper can use. We're converting it into data that Houdini understands. And then we're going to get a write Houdini, right? So we're going to write it to Houdini. So H object. And we're going to get a Boolean toggle. So when we turn this toggle to true is when we're going to write it. So don't turn it to true yet because we need to tell it where to go. And so I'm just going to put these in the same folder that I'm working in now. Now, if you download my file, that part's not going to work for you because you're going to have to put it on somewhere located in your computer. So what we have to do is we just get a panel like this. And we decide where we want to put it. In this case, I want to put it in this same place, which I'm using this folder, downloads. So again, don't copy my path. Put it wherever you want. It could be anywhere. It could be on your desktop. It could be anywhere. I generally put it wherever my Houdini file is. But it doesn't matter. So all you gotta do is just, like if I just right-click on the folder, just go properties, you can get the location. So I just copy that location. In this case, it's that. But then I also have a folder is called downloads. Or actually, it's called 04 downloads, I think. Yeah, so make sure your names are correct. So this is the folder I want to place it in. And then you're going to do another backslash, and then you're going to give it a name. So I've been calling these like roots, let's say. So I'm going to just say roots underscore to underscore Houdini. And then you just have to write .json. So it knows to write a JSON file. All right. So it's your folder, and then the name of your file that you want to name it, and then .json. And we'll do the same for the one down here. So this one is going to be, we'll just call this, I don't know, like pods to Houdini. And you plug those in. Those are the paths we're going to write to. And so now if I click these, if I do this one true and this one true, you'll see now you have that I have here these two JSON files, pods to Houdini.json and roots to Houdini.json. So now I'm going to launch Houdini. So I have Houdini opened here. And if you haven't used Houdini, I mean, again, I'm not gonna cover like every interface. I'm just gonna cover like what I'm doing and going through, because we can do an entire course on just the user interface, and you know, there's tutorials on our website linked that you can follow an entire series for just like the super basics. We just, you know, I want to focus on the workflow here. And you'll have the recording, so you can always come back to it if you feel more comfortable later or whenever you want. So let me I'm just situating my windows here so I can see things properly. All right, so when you know, first thing inside of Houdini, basically you can right click or press tab in the network view to get nodes. So right click or tab. I'm a right clicker, I tend to right click. And the first thing I want to do is we're just going to get a geometry node. Drop a geometry node, and then we're going to double click it to dive inside. So that's how you work. You work inside of nodes like that. So we work inside this geometry node. Okay, so we're inside this geometry node, and we want to use that JSON files. And the first one we're going to use is the pods. So I'm just going to type in file to get this file and just drop it down. And it's just going to do that because there's nothing, we're not referencing anything as a file yet. And all you're going to do is come up here to the parameters, and we're going to pick the place. So Houdini, if you put it in the same location as your Houdini, like Houdini by default opens up the folder that the Houdini file's in. So that's why it automatically went here. And I can just select pods to Houdini and accept. And then zoom out. You see there's my pods. Now, you'll notice they came upwards like this, right? That's because Houdini, like most like software, like Houdini, Cinema, Maya, these kind of like motion graphics softwares always have Y as the up direction, whereas engineering and architecture software usually have Z as the up. That's because, you know, in this kind of softwares where you're usually working with animations and scenes, the Z is like the depth of the scene, but in like architecture, right, Z is the top view because we're usually working in like plan type views. So if you ever wondered why that is, but it's okay. We don't care that it's up like this. We could rotate it if we want, but honestly, it's fine as it is. And so that brings that in there. So before we get started with anything like that, what's really nice now that you've set up that link is you can go back to Rhino here. And if I turn this back on just so I can see them. If I make any change to this, for instance, if I change this shape or something to be something like that, all I have to do is just write that again. And then in Houdini, all you have to do is just come here and just go reload. And there you go. So now you're reloaded automatically, and that's basically the way you work with this link. It's really nice workflow. Once you just set up the JSON files once, and then you're pretty good to go. Can you explain how to import? Sure. Let me go back here. Let's go back to my regular shape here. So first step is to set this up with your path and .json, and then just set them, write them their folder, and you'll see them then in like your folder as JSON files. And then you're just going to go to Houdini, and if you're bringing it in like for the first time, you're going to first start from the beginning. From the very beginning, you're going to start with a geo, and then you're going to dive in there, and you're going to go File. Here. And all you do is you just click this like paper with a mouse cursor, and then just select the JSON file. So in this case, pods accept, and that's it. Then it's there. Yeah, you can F will bring you to photo. Like if you're like, I don't know, like over here or something, you can just press F in the viewport, and it will like look at the geometry. And so let's do a few things here. Yeah, so now we can do things like frictions. We can do some processing stuff, post-processing, subdivide. Houdini is so good with meshes, like just so much faster, and that's why it's like such a nice workflow with Grasshopper, like just knowing the strengths and weaknesses of each. Like I think the whole setup that I did here, this first part, I feel like for me was a lot easier to do in Grasshopper, so that's why I did it in Grasshopper. But then like the next stuff we're gonna do is, to me, a lot easier in Houdini and faster, and Houdini just has a lot of better mesh stuff. So just knowing like the strengths and kind of like what's easier for you in which software, you know. First thing I'll do is if you just press Shift S, you'll see my wire change. I like these rounded wires rather than the straight ones, so I just Shift S and go into like this kind of more rounded wire mode. And so when you want to preview the next node in Houdini, what you do is you just click this blue here, right? So that's showing you the next node, right? So I go here, and then the subdivide is there, right? And then the parameters are always going to be, like the parameters are always going to be here for those things. So if I do another subdivision, and the other cool thing about Houdini is it only calculates what you view, and it also kind of keeps it in the memory too. So if I go here, it's not calculating this anymore, unlike Grasshopper where like it's still calculating even though you're previewing back. And then if I go here, then it's calculating this one, right, up to this step. But because I've done it once already without changing anything, it's kind of like in the memory. So it's kind of nice. You don't have to like keep recalculating stuff. So yeah, I mean, we can give this like a good amount of subdivision. We can say like to 3, like make it very dense like that. And then we'll just get a smooth node. And we're going to smooth it a bit. So with smooth, you have strength, and filter quality. Filter quality is like, it's like kind of like, you see how it's still like rougher? It's like the smoothness of the smoothness. I don't know how to explain it, but it's, yeah. So I'm just going for like 1 here, and we can bump this up. You can just like click there and type like 30 or something, just to get it like nice and round looking. Let's see. I have no idea why without seeing your thing, but you can download mine and see, try to see what's the difference. Possible guesses are you've written something wrong here in the path and the file naming or .json. Maybe you have an extra space. Another possibility is you don't have the right thing plugged into primitives, or you don't have HOBJ into HOBJ. So those, any of those are possible. So feel free to download mine, even though you'll have to change the path. All right, so smooth, and then I'm gonna remesh it. And I'm just doing all this to get like a nicer shape. Just instead of like this kind of like, I don't like that I can still see that edge so hard. So I'm just doing like a bunch of smoothing stuff, and then I'll remesh it. So we can remesh. I don't even know what my remesh. The nice thing with Houdini also is escape actually works on like Grasshopper half the time. It always escapes. So see, like it was hanging up and I just escaped, and it gives me this. Probably my settings are like too high or something. I'm not quite sure. Oh, but it did work actually. So let me just. Also, it gives you a status bar. If you see down here, it says like tells you how long it's taking and at what process it's at in the steps, which is nice. And since it's not reading the right component just a hunch. Yeah, I don't know. It could be anything, honestly. So now that I've remeshed it, I'm gonna do like a poly reduce. And I'll reduce it to percent to keep. I don't know, let's say we keep like 3%. Like let's like reduce it like a lot. Let's see. Just turn that, click that preview. Now you see how it took like a minute to calculate, but now if I go like kind of back and forth, see how it's immediate, because when you calculate things in Houdini, they kind of go into like a cache state. So now once you've done it once, if you didn't change anything, it's pretty immediate. And for good measure, I just drop down always a normal. It's basically like unified normals. Just drop that down. Yeah, it actually did. You can see like the sheen change a bit. It actually did fix something there. I don't know if you can see it through the Zoom screen share, but there's a bit of a change in the sheen there on the reflections. Quads to triangles. Because I don't care about the quad. We don't care about quads right now. We can quad remesh. I mean, there's a installation like, but and quad remeshing is a lot slower. We don't really care about for this process. We don't care about quads because we're going to VDB it anyway, which you'll see this. Triangle meshing is just a lot easier. Now I just want to show you before we get on. We're not going to really do this. So this workflow, we're going to go from Grasshopper to Houdini. I just want to show you how to go back to Grasshopper. So if you want to go back to Grasshopper, all you have to do is get another file node. So if you actually plug in here, we actually set something like from here. But if you actually plug something into file like this, and we give it a name, so we can say, let's see, what did we call it? We said like pods to Houdini. We can say like, I want to just copy the name. We can say pods to Grasshopper. Pods to Grasshopper, and instead of read files, we switch this to write files. And once you turn this on, it's going to write. So once you click that on, what it did was it's going to write. So if I look now into my folder, you'll see I have, maybe I'm not in the right, oh yeah, I'm not in the right location. That's why we want to pick the right location. So I needed that like hip, which is like basically just saying this hip slash just means it's a shortcut in Houdini. It just means the folder that Houdini is in, basically. So now if I go back to that and go there and then here. So now you'll see you have roots to Grasshopper. right? So now we wrote a JSON that we can bring back to Grasshopper. Let me give you that. Yeah, if anyone wants to, again, the files are only up until the point I'm at. So I'm saving them as I go. So that's the link. Okay, so now you have that roots to Grasshopper JSON. So save. So if I go back to Grasshopper here, and let's just say, like, let's say you only wanted to use Houdini just to do like some cool like fixing of the mesh like that, like some very fast mesh fixing. You could then get a read Houdini. And we do the same thing. We need a file path. In this case, it was pods to. So now we need a path that we're reading from. And we need to have the Boolean true if we want to get it in here. But we need to now make Houdini understand. Grasshopper needs to now understand that Houdini file. So we need to convert it into something that Grasshopper understands. And we have a simple component for that in HouGH, which is called Houdini primitive. So if you were bringing in points, you would use points or groups or attribute. But in this case, we're bringing in a primitive, which is a mesh. So this is just going to convert it to geometry out. And why am I getting yellow? I must have typed something wrong here. Space. Let's see what's. Oops. Ah, I named it wrong. Stupid. See, naming matters. So this one actually should have been, because it's not the roots, it's the pods. So write it again. Okay, you just toggle to turn it on when it's in write mode, and it will write it. So we actually want these pods. So I'm just going to delete this one to delete the roots. So just, there you go. So now you brought it back into Grasshopper. Right? So that's how you just bring things back into Grasshopper. Osman, are you also using Mac? Okay, so that's how you bring things back into Grasshopper. So that's kind of the workflow. You can send things to Houdini, do things to Houdini, bring them back to Grasshopper, do more stuff in Grasshopper. Simple as that. If you can't get it to work for some reason, I don't know, it just means you're installing something wrong or something, because clearly. So if you can't get it to work, then you just need to, basically what you have to do is, for instance, if I wanted these pods, you would just bake them and then do file, export selected. How do we check what is desktop? Yeah, 1 second, I'll tell you that. Desktop, and then you can just export like as an OBJ and say pods. I'm just going to put it to my desktop for now. So if you can't get HouGH to work, you can just, it won't be as simple as this like reload, unload. But you can just export, bake geometry, export it as OBJ, and then here, when you get the file, you can just select the OBJ. So if I go to my desktop, accept, and right, so there's the OBJ. But I have a weird setting. I have a different setting in my OBJ because I've changed something there. So just make sure actually when you export file, export selected, OBJ, odds, options, you can just turn this off, map Rhino Z to Y. So you can do it in the same way that we just did. And if you wanted to get it out, all you have to do is on any component, like at that stage on any node, sorry, you can just do save geometry, and you set the type to OBJ, then name it. We'll pick a location. If I do my desktop, odds, accept, and that will write to OBJ, and then you can just drag that OBJ in if you want. And you can turn off this map thing also and get it back there. So that's just the manual way to do it. If you can't get HouGh to work for some reason, but I can't really see why HouGh wouldn't work unless you've installed something. Okay, so moving on. If there's an error, how can I trigger an error here? I guess if I named this wrong, maybe. Actually, I have to save this too. All right. So if there's an error, like for instance, if I named this wrong, it should be an error. There is no ODS. Yeah. So if you have something like that, when you hover, you get this kind of stuff, right? So you just click this, and it will tell you errors, unable to read file, whatever. That's the error there. Then just when you fix it, and you just go back to the blue. Like by clicking it by blue, it will update. Will space in file path? It might. I never use spaces in file path, but it's a good question. It might cause an error. Maybe don't use a space. Try it without the fixes. I don't use really spaces in file paths and names, so because some software like Maya has a lot of problems with spaces and file names and stuff, so I don't really ever do that. Other thing to note while we're here is you can bypass, like say I didn't want to do this smoothing anymore, you can just bypass it with this arrow. So if I turn it off, actually I should go down here. So, now you'll see because I reloaded that geometry in from the error, so it took a little bit of time, but now like that I did it once, it'll be okay. So I can actually bypass. So if I turn off the bypass, you'll see it. Now it will be smoother when it finishes. So now it's like a bit smoother there, and then I can bypass it if I want to not do that. And you can bypass anything. It just like basically just passes the data through without doing anything. And the other thing is the purple, which is a good one to know too. The purple tab will let you like preview something as a template. So if I turn that on, see like I'm previewing that thing without actually being at that step. So like say I wanted to just see what like the original mesh was like, I could just like use a template to see it, which is the purple there. All right, moving on. I'm gonna copy over. You don't have to copy like over. I'm just gonna copy over just so like we remember the steps that we took. The steps that we took as we were going along. What about the gray parts? What gray parts? Maybe more specific. Some polygons. I'm not sure I follow. Some polygons. Aren't they all gray? I mean, feel free to also download my everything here, my JSONs and all that, and set it up because you can compare to see what you're doing wrong. I don't really know what this some polygons gray mean. I have some polygons that are gray. I don't really understand. So for now, we don't need this, right? That was just to show you how to bring it back to Grasshopper. What we're going to do is we're going to turn this into a VDB. VDB is like a voxel space, a very fast voxel space. If any of you use Dendro, Dendro is also using VDBs, but it's much quicker in. So we're going to get what's called a VDB from polygons. And just before you preview it, click the node, but we want to make sure we look at the voxel size, because if you have a very small voxel size, it can take a long time. So I'm going to make it like 0.5, let's say, then turn it on. So that's our kind of, that's the way it's previewing this this voxel space, right? I don't know if you ever use Dendro, but Dendro is definitely not that fast. I mean, so, and that's just, Grasshopper thing, and Houdini is just, I mean, this stuff is kind of like made for Houdini. Okay, so now you have this voxel space. And once you have those voxels, you can do cool stuff with them. For instance, you can reshape them. So if we do like a VDB reshape, SDF. SDF stands for signed distance field. I'll write it here if you want to look into them. A lot of math stuff that don't have time to explain. Signed distance field. So plug that in. So what the reshape will let us do is, for instance, we can offset our VDB, right? And keep in mind these aren't intersecting with each other. It's one cloud, right? So it's going to be like one kind of shell, let's say. Or you can also change here. So that's dilation. You can also erode if you wanted to go inwards. You can erode. So let's, we can dilate it by like 1, just go a little thicker there. Again, these are all just settings you can change and mess with. So what we want to do is kind of we want to create a volume. It's called a volume fog within this. It's going to be a fog that's going to be like a pattern, and you'll understand once we do it. And actually, I think this particular trick I learned, I picked up from Zanette, who's one of our tutors. I think I caught her doing this specific trick in something, one webinar she was doing. Thought it was really interesting way to do it. So yeah, if you don't know that SideFX, you can follow her there. I'm pretty sure that's where I remember this from. So anyway, so what you're going to do is you're just going to get a box, and you can make it a bounding box by just plugging something into it. So we just plug that in, and now you got the bounding box. And we're going to do a VDB from polygons, and we're going to create this box into a VDB. But we're going to do a different kind of VDB. The VDB we're going to do here is called a VDB fog. So you can see it here. So we're just going to turn that on. And so now you see it's kind of like this milky fog volume. And we want to give it a smaller voxel size, so something like 0.05. You won't really notice much difference, but it just like makes it a lot more dense for the next thing we're going to do. Let me just see. And we're going to get what's called a volume VOP. Volume VOP. Now VOPs are the point, the vector operators. They're like the point at which Houdini becomes like Grasshopper, I would say. Like all of this stuff isn't working like how Grasshopper worked. It's working in a much different way, but VOPs are working pretty similar to Grasshopper. And VOPs are kind of like, they're kind of like the node version of Vex. Vex is like Houdini's scripting language. It's like the difference between C# and Grasshopper would be like kind of Vex and VOP, if you will. At least that's the way I like to. At least that's the way I like to think about it. So we're going to just plug this into the VOP here and turn it on, and basically it's going to do nothing because we haven't done anything in it. But with VOPs, basically you just double click them, and then you're in this kind of Grasshopper-esque, you can do it Shift S, node editor, which will feel a lot like Grasshopper in the way that you connect things and the things you do. And we're going to use here the kind of noise. And so that's just going to be the output. If you want to disconnect the wire, there's a few ways. You can just like select it and delete it. I like to use Y. The Y will give you like this scissor. You can just like drag it to delete anything you want. You can also like jiggle. I can never get the jiggle. I think my screen is too big for the jiggle to work, but you could like jiggle it away. Like, see how I just went like a madman there and jiggled it. But I just can never. It's just very. Maybe it's more gimmicky. I don't know if anyone actually uses it. So let me just disconnect that. So we're going to use a noise, a flow noise, low anti-aliased flow noise, and we're going to plug the P, which is the vector positions, into positions. So basically what we're doing is we're going to create a noise within this fog, right? We're basically going to eat away parts of this fog with a noise. So you see there's all these parameters, and we can play with all that stuff there. And we want to give that noise also like a sine wave. So we'll get a trig function. So we'll take that noise and we're going to give it an additional sine wave. And this has its own options. And then we just output that. So this is the output of the volume. Now, you'll notice if I go back now, not much changed because with whatever the settings are the same. But before we get into that, before we change the settings, I want to show you how to, because when you're in these Houdini nodes, it can be annoying to like dive in here and then like click here and like change all these settings and then click here and change these settings. So we can bring those settings up to this level here. And the way we can do that is you can just right click. Did something. Grabbing the wrong thing there. There was a shortcut, and I can't, for some reason I can't remember now. There was a shortcut to just send them all. So I don't really want to do them one by one. Give me a minute. Only take like 5 minutes to get this, and let me just look up what that shortcut is. So just take like a few minutes. Is it middle mouse? Is it work? Yeah, I know that. Well, I know, okay, so I can promote, but I thought there was a way to promote all of them, but maybe not at the same time. But anyway, so you can go per input and then just go promote parameter, and it'll give it like this little tag here. Yes, I know the middle mouse. I thought there was an option that you can just, I'm pretty sure there is, that you can just all of them at the same time. So frequency is now out, right? So now you can control frequency here. So we'll just promote those parameters. Just to make this a little bit quicker, I'm gonna like preview the box up here just so it's not calculating every time I change something. So promote. All right, so now you have all those options out on the outside here. The other thing is like, if we want the trig too, we run into a big problem. We can't just promote it because, for instance, there's frequency and frequency. So if you try to promote frequency and offset to the same menu, what's going to happen is they're going to override each other and cancel each other out and then disappear. So we have a node for that, which is the parameter node. So instead of promoting a parameter, you can also just use a parameter, which is like this yellow thing here. And if you just give that a name, for instance, I can call this trig frequency up there in the name, and you see it change there. We can then bring that here, for instance, and we can set a default too. So our default can be, yeah, it's the default. It's fine. Here. So now if I go out, you'll see I have to trig frequency. Right? So that's just like, you kind of want to do that so that you don't override those inputs because they have the same name. And actually, if you want to make it even more, you can give it a label, and we can make the label like meter, because like the name shouldn't have spaces really, and usually you write it with lowercase. Label, and we'll do it another one. We'll just name this one like trig offset. And trig trig, we're gonna change. I'm gonna change the trig to a sine wave. So we'll just move the sine wave. So if I go back, now you'll have all your your frequency and offset trig. They don't override the other ones that are named the same by default. Okay, so what we want to do is we want to adjust the values. So I'm just going to, values can be anything, but I'm just going to make them. I'm going to make them what I had before because I think we're in a similar scale. So I'm just gonna change all the frequency. Now you can actually write in there, like if I wanted this to be 7 and then this 1, 1, 1. But I want them to be the same in that case. Notice I'm still on box so that when I change values here, I'm not like recalculating every time. So you can also middle mouse button and then like come up and down this, and that will be like the interval. And then if you go left and right, it will be like the amount in that interval. So if I'm on 0.1 and then go left, you'll see it'll change all the things there. So I can make that like 0.7. In this case, and again, these numbers are just what I had before, so I know like what they look like. But feel free to experiment and make them anything you want, really. Oops. And I had the trig frequency, and I had it 50. And that should be so let's just turn it on and see what we got. Yeah, so you see it's like a much different thing now, right? It's basically the fog of that geometry you see in like the preview images. And again, now you can change these frequencies and all that, and have fun with it and whatever. And so now we're going to do a what do you call? If you want to get this back, you just do convert ADB. If you want to convert to polygons. So we're going to just convert this. So now we'll make the actual mesh. And you just give it, give it a minute. It's not its first time, and now you have this like crazy mesh, right? Mesh version of that thing. And if you want to preview without the what do you call it, the edges, you can come here to this box and do, like right now I'm in smooth wire shaded. You can just do smooth shaded if you don't want to see the wires. Okay. And then, but what I actually want to do is, I just want to show you the mesh, but I don't want to convert to mesh. What I actually want to do is I want to convert this to a VDB instead of a fog. I want to convert it into a, like pixel VDB instead of the fog kind of VDB. I mean, it's not my really problem. I mean, I can't hold everyone back because we went to the bathroom, but volume VOP is noise, trigonometry, and 2 parameters, and then bringing these parameters up to the front and then outputting. That's it. So, and then what we want to do is we have this fog, and we want to make that into the kind of VDB that we had like here, this kind of pixels of VDB. So what we do is we want to convert to VDB, but we want to convert we want the VDB class to convert fog to SDF, signed distance field, fog to SDF. And so now if I go here, we should have now that geometry in the kind of SDF kind of voxel preview stuff that you're seeing like here, this kind of stuff. So if I zoom in, you'll see it's that kind of instead of a fog. So the interesting thing is that now that we've got two VDBs, we can do a VDB intersection, which is really nice because you can. It's a lot quicker than like trying to boolean some meshes or something. So if we do like a VDB intersect, and it's going to ask us like the operation, and we're going to say SDF intersection. We want to combine A and B pairs, right? So there's one here and one here. And we can leave it as it is because it's already set to intersection. And basically, we're going to intersect this. So look at the first one and the second one. We're going to say this one here and this one here. This one here. This one here. And also, if I just click on that, you'll see how quickly that was done. So now you have the kind of VDB in those shapes. And then we're going to do a loop, but in a minute, because what I don't want here, which is what we did, is it's all together as one. So where those points are, we kind of lose the pods, right? Because they join together. But before we get to that, what I want to do is show you a bit quickly about using this timeline here for something. So what I'm going to do is I'm going to go to the volume VOP, and I like to use the flow rate. So flow rate is going to change like the position of these things. So if I change this to like, it's between 0 and 1, right? So if I change it to 0.5, just give it a minute, you'll see that the kind of flow of this noise will change. See, so it changed, right? And it's actually a pretty fluid. Oh, I changed the wrong thing. I want to change flow rate, not flow. Or we can change flow. Both of them are doing different things. They're both fun to play with, but I was actually right in the beginning. I want to connect the flow to the frames because it's actually pretty fluid. You can use Dendro, but it's going to be slow, especially the next stuff. So use the right tool for the job. Okay, so what we want to do now is we want to connect to the frame. And the easiest way to do that is we can say, and we know it's 0 to 1. So what we can do is we can say at frame. At frame would help to spell it right. With capital F, because at frame is something that Houdini understands. It's a parameter in Houdini that understands that we're using the frames. And we're going to do divided by 100. Okay. And the reason we do divide by 100 is because it's 0 to 1. And what we can do is we can just make, just resize. You can just, we can just change this to 100 frames. So we'll say the maximum frames is 100. And so now I can control this flow with the slider, although it's going to be pretty slow. For instance, if I went to 50, frame 50, it's going to be flow 0.5, right? So just give that a minute. Okay. So what you can do, I just want to, we're not going to do this like for the rest here, but I want to show you, this is a pretty important part of Houdini actually, which is file caching. So let me just, so when you get to a stage like this, and you have something like that you like, you can use the file cache node. File cache. So the file cache node, what it does is it basically, by default, it's going to do all the frames. You should do all the frames, but not now. It could take a while. I'm going to only do like maybe like 20 frames. Basically what it does is it runs through every single frame and caches that geometry. And then once it's done, you never have to like recompute that again, unless you change something else. And it will have that all kind of computed and figured out. Or does it need to type the forward F? Not alone. I thought dollars, I think, I don't think it works at F. I think $F, that's the other one. You can do $F or at frame. I don't think you can do at F. It used the old school way is $F like that. But in recent Houdinis, they've made it a bit like more intuitive to under, and they just used ats, so they made it at frame. So either one of those works, $F or at frame. I like the at frame just because I just can read it and understand it better. So what you would do is once you have this here, all you have to do is click on save to load from disk and save to disk. So we're going to click load from disk. There's no cache yet, so it's not going to load anything. So if I click that, there's nothing because we haven't saved the cache yet. That's save to disk. And if you just want to do all frames, you just do it, save to disk and let it go. And this menu will come up and it will do its thing. But in this case, I want to just do like frame 1 to 20 just for the sake of time. So what I'm going to do is I'm just going to right click here because it's green. I'm just going to delete the channels so that I can type, for instance, 20 here. So we're going to do frame 1 to 20. And I'm just going to put this and then save to disk. And don't mind this. This is just Redshift stuff. But in a second, we'll see another menu pop up. You can see it here. Should look like something like that. So let's take a break while mine does those 20, and we'll come back in like 5 minutes. Okay, we're back. And it seems that that cache finished. And just make sure you have load from disk. And you can actually see, if you go to Houdini file, you'll see now that there's this geo folder that Houdini made. And that's where your cache went. So it made a cache for you. So there's the cache of those 25 versions. If you wanted to know where that went. So now what's really cool is I can go, I only did up to 20. So I can like easily go, between those that I cached, right? Without having, now I don't have to load it anymore. Unless if I change something up here, change some value or something, then I'll need to cache it again. But caching is good for like when you're pretty much set in like your settings, and then you want to do some kind of like something with the timeline, kind of cache that movement. So you don't have to calculate it all the time. So now it's calculated. So now if I just hit play, it's going to go up until 20 and it's just going to disappear because I don't have the other ones cached and I'm in the cache node. So if I just hit play, it's going to do something like that. And then after 20, it's just going to like disappear because I haven't cached those. But caching is really powerful part of Houdini because you can just do it once and then it's good, and then you can do your animations from those caching. It's really fast. You don't have to calculate and then render. But we're not doing much caching. We're not going to do any like caching. I just wanted to show you about it because I think it's an important part to know about how to do that. So that's caching. Now, the thing is like I said, we don't want everything to kind of like join together. We want to do everything separate. So we should do this for each piece of that pod rather than like the whole pod. And if we were in Grasshopper and we wanted to turn this off, go here. Before I joined it together. Like let's just say we had something like that. Before actually I can split it up over here. Chunks here. If you want to get it back to read as multiple meshes instead of one mesh, you can do disjoin the mesh, and it will basically just make everything that's not touching into its own mesh again. So now I have 10 separate meshes. So if I wanted to do, let's say, a bounding box around each of those things, right? And let's just say for the sake of argument that the per object option doesn't exist. Let's say that there was only a union box option. Well, what would you do you would graft that data. Right. So you're basically matching a list, right? You're basically saying that there's these whatever 10 meshes and you're doing something to or if I wanted to like move, let's say I wanted to move these up, but at different intervals, I would need a series. Actually, I can do a range, let's say. Range. And we can measure the length. This length. Now series is in steps, so it's going to give us like one extra. So we want to do this list length -1, and I have in Pufferfish just like a stupid x -1 because I hate typing. So you can just do x -1. we can do Z. We can give this a, let's just say, construct domain. Construct domain. Like 0 to 10. So you see how I've like moved all those, maybe it could be more obvious. Yeah. So see how I moved all those pieces individually at their own distance. And the way to do that in Grasshopper is list matching, right? So we have ten meshes. So we need 10 values, and that's list matching, right? So we don't do list matching in Houdini. What we do in Houdini is loops. We loop things. So we're going to say, like, you know, for each mesh, do something. And that's more like scripting. So, you know, Houdini is kind of closer to, I'm just going to put this here and just keep it up. Back to this video or something. So what we do in Houdini is, instead of list matching like that, we just do loops, which I find more intuitive. And so what I'm going to do is I'm just going to turn something on that's simple, like this box. Or when I copy it, so I'm going to calculate. And we don't need the cache, right? The cache there was just to show you like what caching does. So I'm just going to take all that and then just Control C, Control V. Just next to it. And just remember, you don't need all these steps. I'm just copying over as we add more stuff. So we can run this in a loop, and we do that with, if you do for each, we get some loops. In this case, we want the for each connected piece. So if I drop that down, it's going to give you these 3 nodes. Connectivity, basically what connectivity does is it says, okay, there's, after this normal, it's basically saying each piece that is its own thing, right? So they're a connected piece. In this case, there's however many there are. So you just drag that in. So in Houdini, you can just drag things like that and it will connect by itself. And then after connectivity, we need to put the beginning of the loop. So the loop's going to begin after connectivity. And this is going to be the end of the loop here. So now what you're doing is you're saying for each piece on its own, run this operation as a loop. And then what I like to do after loops is you can put like a null. Just makes it neater, like so you remember what's the output. Null in Houdini is different than null in Grasshopper. Null is almost like the parameters in Grasshopper, like curve or data, or whatever. It's just like an output. So now, if I run this, it could take a bit longer, but you'll see what it does. So just going to turn that on. You can see it cooking down here as it calls cooking, and it tells you what it's doing and how far along it is, right? So now you can see, I mean, there's a bit of overlap because I dilated those things, but you can see that they're not anymore like connected as one piece together. There's a much more distinct line because it ran that operation individually, and that these two VDBs aren't actually connected. They're just intersecting. They just happen to be overlapping at this point. But, see like the hard kind of line there that's separating them. So that's how you run things in a loop there. What's also nice for testing is when you're running loops, if you go up to the start here, you can do a single pass. And this is good for like when you're testing stuff. So if you just do single pass, it's basically just going to go and do the item that you put here. So that's the first item, item 0. So it's just going to show you, it's going to run the operation only on that. So if I wanted to see the third object, whatever it might look like it's a nice way to like quickly see how things are done before you do everything. And I can actually turn on the template of the normal before, so we can see what's happening like that. So single pass will let you just see kind of like what's going on individually per pass. And when you're ready to do it all, you just turn off single pass and it will go through and do them one by one. So you can turn off single pass and then you'll do all of them, but individually. All right. Now, kind of even further magic that isn't really shown often ever is what's called compiled blocking. And compiled blocking, the concept is very nerdy and computery, but it's already multi-threaded. Houdini in general is multi-threaded, but if we get what's called a compiled block, it's going to give you these 2 nodes. And you can basically wrap those around before each. I suggest when you do this, actually do what I was doing before, like turn on something else that's not the end, because then you'll calculate it each time. So we can just maybe turn on the connectivity. And then we can wrap this here. And you see it like wraps around everything, right? So now it's a compiled block. And what you want to do is if you go to this end here, the for each end, you'll see there's a multi-thread when compiled. So you want to multi-thread. So what that's doing is, and you can look up online about compiled blocks in the Houdini, like if we go to blocks. So you can read about it here. So compiled blocks are for multi-threading, but they basically do some magic in your memory, in your computer's memory. And it can significantly increase speed. But there are some drawbacks which we'll get into in a bit next steps. But the nice thing is like once it's a compiled block, like if I go here, I can just go right here and then it's like immediate, right? Like it just didn't even, it was just immediate. So what a compiled block does is when you run a loop and like you get to a point, basically what's happening is your system computer memory is making a copy of that geometry, doing something to that geometry, and then bringing it back. What a compiled block does is it says, okay, instead of this being a process of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nodes, so instead of this being a process of 10 nodes, make it a compiled block that says now this entire process is one thing. It's not 10 separate things. It's one thing in one place in the memory, and it only exists there. There's no kind of like copy, right? So, but you don't really need to understand that. Just understand that for the most part, it makes things a lot faster. But there are drawbacks, which we'll get into, which is you can't do compile blocks if your thing you're trying to compile block is referencing things which are external from the kind of loop or block. Like, so I can't have something out here come in because it can't invoke that from memory, right? Because the compile block needs to have everything in it within its own memory space. So that's one of the drawbacks, which I'll show you in a few next steps. But when you can use it, it's really powerful. And the other thing we won't use now, but you should look at because we don't need it right now because we're just doing one thing. If I can spell correctly, invoke. So there's invoking, right? So that's really cool because you could like have this block as a type of thing, and it's almost like a method or a function in scripting, and then you can just invoke it in other places with this. Instead of having to like copy all of this, you can just invoke it by name as a kind of function, which is really nice. Instead of having to like copy this everywhere that you want to use that like process basically, and then it would just be like the inputs and outputs. Almost like a cluster, if you will, but a very efficient cluster, if you're familiar with clusters in Grasshopper. So once you have that, and we have that, we can have this thing, just copy it. I like to copy it at each step. I feel like a lot of people don't really know about we use it so much, the compile blocks. They're really, really great stuff. I'm actually just going to delete them here because I want to have you the version so you remember without the compile block. But yeah, just read about it. I mean, it tells you exactly what it does here. And a compile block or multi-object key data on the Gravis cards, process it without copying it back, increasing the speed. It's just behind the scenes stuff that's very optimized and efficient memory computer stuff. So. Okay, so now that we have that compile block, let's okay, so next thing I want to do is I want to again, it's going to calculate now because this is like a copied compiled block. It's not the same compiled block, it's just a copy of it. So it's got to like do its kind of computing right now. But now it's good. And then we're going to get a VDB smooth. And we can smooth this a bit. Just get rid of those that roughness. Default is fine. Whatever originally was set to is good enough. And so now we want to bring in those roots that we made. So we'll just go File. We're going to bring in those roots, which were roots Houdini. Right, so now we have our roots there. And we want to VDB those, but we want to make sure that the VDB that we do there corresponds to what we did with this VDB from polygons. We want the same voxel size so that they join together correctly. Otherwise, it's going to pick, when it joins, when we do like joining and stuff like that, it's going to pick I forget if it picks the smallest of the two voxel sizes or the biggest. So we just want to coordinate that. So, but one is a fog and one is the SDF. So a really nice thing you can do is we can get the VDB from polygons. And what we would do is we come to this one here. And I like to color things that are like, just so I remember like that they're connected somehow. So if you just click this little like color palette, you can just color the node. So I'll make it green and I'll make this one green so that I remember that they have some kind of connection between them. So I'll go here and you're just going to right click on voxel size and you're going to go copy parameter. And then in this one here, you're going to go right click and you go paste relative references. And it's going to look like that, right? So it's basically that code that it put is saying reference VDB from polygons 8 voxel size, which VDB polygons 8 voxel size. And you can double click it if you want to see the actual value or the code up to you. So now they're together. If I change either one of those, both will change in that parameter. Okay. So put that in, get the VDB of those. And we'll do some reshaping and smoothing. And remember, reshaping and smoothing don't change, like, don't really change the voxel size. They just change like the amount, so that's okay. As long as the two voxels are kind of in correlation with each other, we're good. So we can reshape this. We can do another like dilate one, just makes it a little bit fatter. But you can play with that also, and then we'll do a VDB smooth. We can do VDB. I'll just use SDF just so I mean they're you can they're both pretty much do the same thing, honestly. Smooth, and you could smooth it a bit. Before I had like 4 and 7 to get like this kind of like more like gooey looking thing. You might break some stuff off there. If you care enough about it, you can change the filter voxel radius, or just like play with those settings. Something like that. It's cool. And then we'll do a union. So we'll do a VDB SDF union. And what we're going to do is we're going to set that union to flatten all B into the first A. What that means is here we have now, if I go to info, here we have 10 VDBs because we did it in a loop, so they're all separate, versus like before we did them in a loop. If I actually go back here to here and go to that, I think I put the flag on this one. So if I go here and go info, see it's 1 VDB before we did the loop. So what we do is we're saying flatten all B into first A. So we're saying take all these B's and union them to the first A. And we only have 1 A, so that's why that works into the first A. And that's the only other setting. That's the only settings we need for that. So that's our A, and we're going to flatten all these B's into that A and turn that on. So now they're actually 1 VDB. So if you were to make this a mesh, they would be 1 closed mesh. And, you know, you can play with these things. Like if you wanted to see more of that like cross connection, you can just come up to like where that was, which was like, I guess that was here in the reshape. You can erode it. Let's see what that does. So that's like too much erosion, but I mean, you get the point. Basically, with the idea here is I was trying to make like these pods with like these kind of veins between. We eroded by like 0.1. Even that's up to 0. Eroded by 0.0. So I mean, this stuff just takes like a bunch of, you just play around with it, you know, and you can create some stuff. Even then, still, not drive me crazy. Okay, maybe 0.005. Seems like a, what is that? I'm trying to erode it like so small, just this little. Oh wait, it's because of this. They're so low poly. Yeah, I think it's because they're just so low poly. And I want to make the BDB voxel size also. Okay, that's why. I mean, we can make the voxel size like a little bit smaller. So when we reshape it, it should be better actually. Get to the end here. A little bit better. Anyway, we can stick with something like that for now. Or actually, I have one more idea. Maybe we can put this back to 0.5, and we can actually dilate instead of erode. I think actually we should dilate, but it's less than before. Before we were dialing by 1, maybe we can dilate by like 0.5. Yeah, that's better. That's kind of like what I was looking for. And yeah, again, like I said, like it's can be messy, or you can clean it up by like playing with parameters. But I kind of like that it was like semi following the shape, but also like kind of broke out a bit. That was kind of interesting. Okay, so now you have this thing. The next step, so the union is you just set it to flatten all B into A, and it's just going to take all the B because there's multiple VDBs. There's 10 of them, and it's going to flatten them all, basically union those all to the one. Here we just have one VDB. So all of these unions to the A. And I just want to, if I change these, it would, if I change this green one here, it would also change this one there. So like they're kind of correlated together. So next thing we're gonna do is make copies. So we can get the copy stamp, which they copy stamp. It comes yellow. Just keep in mind, like yellow. I don't actually know why copy stamp is yellow, to be honest, but that it is. But colors like that don't mean the same thing as in Grasshopper. Like yellow doesn't mean there's anything wrong. It just means that it's a color. Like C compiled blocks are like this yellow. So we're gonna make copies of this geometry, and this is like a duplication kind of copy, which is kind of nice. So we can play with those settings. Yeah, I've been saving it so much. But you'll need to relink to your JSON files. Just keep that in mind. Or my JSON files, if you want to use the ones I've saved. Up to you. All right, so copy. If we go to the copy, you can do a bunch of things. First of all, is a number of copies. And I was doing around 3 or 4 for the designs I was doing. Nothing happened because we haven't changed any values, but they just have translate, which is move, scale, rotate, and it's going to do those like kind of sequentially. I actually have a component. I have in Pufferfish. I have this transform, recursive transform. It's basically the same thing as what this is doing, and Maya does this too. Like you keep doing like the kind of copying there. So translation, I'm just going to put for start, I'm just going to put the values that I had before, and then we'll play with it. I just want to get to like a base point. I'll show you how to edit it. And for scale, I have them all at 0.8. Share scale. 0.8. Yeah, sure. I'll put okay, so if I turn this on now, you're going to get something like that. Right? Because we've copied it and translated it and rotated it, whatever. And you can just play with these. If you want to play with all of them together, remember you just right click on the name and use this mouse thing, or you can right click in a specific field and play with it too. Like if I went to here, so you can see how that's changing. So play with those and you get like this kind of base shape that you want to do stuff with. Scale also, you can scale non-uniformly. I like the uniform scale. Movements, you can move Move. Oops. Too much. Do that. Just get it. I like the overlap because they're gonna be VDBs together anyway, so I like them to kind of smooth together. So I don't know, something like that. It's kind of cool. Copy, and then we're gonna be doing a union again. So we'll get the union. But in this case, we're going to use the union, and we're just going to say flatten all A. So we're just going to take everything. And that's just because right now we have the copies. We have 4 VDBs, and we want to make them as one VDB so that they basically smooth together. So we go here and we just say flatten all A for union, and then put in A. So visually, there isn't going to be much of a change. You can see a slight change when I switched between them. But if I come here and go to I, you can see that they're all one VDB. So now we get to the part where we're just gonna like kind of mirror this thing around. And there's kind of 2 ways to do this that I wanted to show that I think is really interesting. So let me just copy this over again. Just gonna click on something that's this. But you can see that like Houdini is in this density of things is a lot more forgiving than Rhino Grasshopper is in terms of calculating those meshes and even just dealing with them in general. When you have meshes of some of this density, you can barely even orbit around the Rhino viewport. So it's just really knowing about what tools for what. And for instance, like, we showed before, I showed you how to bring stuff back into Grasshopper, but like I wouldn't dare bring the results of this back into Rhino. It would just be too heavy. So you really want to use that kind of back and forth workflow for like more simple, small things. Like you wouldn't want to bring this heavy of an object back into Rhino Grasshopper. So yeah, so okay, so we have the union. So let's mirror it now. So we'll just get a mirror. Yeah, it could be tragic. And again, I just know these settings from before of what I liked, so I'm going to set them, and then we can play with them. So if I go here, so distance. So the mirror is always going to be at the origin, right? And then you can set the direction, which is like XYZ of the plane. And then distance is going to be like how far away from the origin that plane is. And I'll show you what that means. So if I just plug this in and mirror it, you get this, right? Now that's in this X direction, right? So we mirrored to the X direction. And it really looks pretty nice. If we want to mirror in another direction, you can do like, you just zeros and ones is all you need. It's like basically 1 means yes and 0 means no. So like now I'm mirroring across like 2 directions. So I've got something like that. Say I wanted to only mirror across this direction, that, etc., etc. So for now, I'm just going to keep it like mirroring across just the X there. And you can change the distance, which is kind of like the offset from that mirror plane. So if I did something like 4, you can see how it like moved apart, right? So if I actually change that, you see it. So you can kind of define your, however you want your kind of overlap conditions to be. Get some really interesting stuff pretty immediately. Oh, well, let's just say something like 4 is kind of, I like that it kind of created this opening. And then we're going to mirror again. And you can mirror as many times as you want, really. I'm just going to mirror it twice. But feel free to go mirror crazy if you want. And in this mirror, I'm going to do also a distance of, I don't know, maybe 4. But I want to mirror it in the other direction, downward. So I'll just go 1 and 0. Oh, I'm changing the wrong one, of course. So change this one. That 0 and this 1. That. Houdini is the units are kind of irrelevant, but Houdini is default in meters. But as you saw when I brought my stuff back into Grasshopper, as long as your settings are like the same here, like it'll convert properly. Like so if you have like point whatever meters would equal, you know, the millimeters. And stuff like that. As long as the dimension is correct, then the units don't really matter. So now we have this kind of thing here. That happens like pretty quickly, right? And again, you can always go back, like for instance, and you can go back and change anything really, and it will, you know, come downstream. You know, maybe you want to change the copy. Actually, I left something out like that I did before, so let me just do that real quick. What I actually did before was to make it even more like complex looking, was I actually did this twice. So I did like I'll just copy this. So that I had more, and then in this one here, I did like a very slight, so I'm gonna put all this stuff back to 0. This is just like a stylizing thing. And this one I moved everything 1 unit in XYZ just to get like this cool kind of like offsetting look, which I'll show you here. So now if you look, it's like we have those that we had before, but if I come to the back, you see you have like this kind of like these like duplicates that are like slightly offset too. So you get like, I thought that was pretty cool to kind of like bury that in there. So again, you go from like this to like a slight offset like that. I thought that was pretty interesting. So then we could put that into the mirrors. Much better. I was wondering why it wasn't looking so complex as before. Okay. So the other thing is like the other way to maybe want to mirror where we don't have these things intersect. What we can do is we can convert to VDB. convert the VDB to a mesh and do some like clipping. So I'm just going to do convert the VDB. That. And we're going to convert it into a polygons. Don't change it in settings, don't really need to, and then just click that. Let it convert into a mesh. So there's our mesh. And you can see when it converts into a mesh, like how all that stuff, because of the VDB, it all becomes like smooth together. It's not like intersecting, right? Which is nice. And don't worry about the roughness. We'll like smooth that out afterwards. For the final shot, we'll make it like a bit denser. So we'll do that. But the important thing is to know is that like it's all kind of together, right? It's not just like this messy intersecting model. That's the beauty, the beauty of VDBs. Okay, so now, and actually you would, I mean, despite the annoyance of having to clean this thing out, and also probably you would have to check for some thickness things, but in theory, you could 3D print this thing. It should be a watertight closed. So what we're gonna do is we're gonna a clip. So clip. In that clip, we want to give it like kind of the opposite of the settings we had for the mirror. So what we're going to do is we're just going to, here you have same stuff like distance, but I want to connect it to this mirror here so that they have the same settings. They just do a different thing. So I'm going to come here and I'm going to go to distance and I'm going to do copy parameter and I'm going to come here to clip distance and paste relative reference, but instead, because I know the way, so the clip kind of works opposite of mirror, right? Because if you're mirroring something, if you want to keep the clip, it would be the other side, right? Like, because you're not mirroring, you want the other side. So just take negative, just put a negative there in front of the expression it gives you. And for the direction, we know we have 1, 0, 0. We want to also go opposite of that. So we'll just do copy parameters here, paste relative references, and we can just make them all, even though we're only using the one, like just in case we decide to change it, let's make them all negative so that they would correspond in the future. So I'll plug that in. So we'll clip it. And so now if I look at the clip here, once that calculates, right? So you see we've like chopped it off, right? Where the mirror plane would be, basically. And then we'll just mirror. Now we'll like mirror it the same way we did here, but we'll mirror it with chop, so you won't have things coming across the mirror. So it just really depends like what style you're looking for. And so the mirror should have the same options as the other mirror. So what you can do, instead of doing, like if you know the whole entire node should be the same always, and you don't want to do it by reference, a nice thing you can do is you can just right click and go to actions and do create reference copy. And it's going to create a copy of that node as a reference. And it even says referenced from mirror 1. So now anything you change in either one of these will change both of them. So, and we want to make sure we use the same settings. So put that on. This process is a little bit slower because we're working with the actual mesh instead of VDBs are a lot faster. But we Oh, we can clip a VDB, but it's a bit different. There's VDB clip, but you got to use like masks, and not really trying to get into masks right now. It's easier to just use the plane that corresponds with the mirrors. Okay, so there's the difference, is that like now that you've clipped it, anything that's past the kind of mirror plane won't, it's clipped away, so you get a different kind of aesthetic, something like this versus something like this, which you'll see the pieces will come past, right? So depends on the aesthetic you're going for. I like both. I think they're both pretty cool. But now we need to make the clip for the other condition as well, the downward condition. When something is green like that, it means it's referenced to something, either the timeline or some other node, just so you know. If you were wondering why it's green there, that's because we referenced that. So another thing what I want to do is I kind of want to do what I did before, is I know that these three are all kind of relating to each other, and like this one's referencing the parameters of this one, and this one's literally a reference of the entire node. So I'll just coordinate them with some color, and you can even, like, if they're lined up like this, you can, like, I can't do it here where there's like this green and green are connected, but since these are next to each other, you can do, for instance, like this here that is called network box. You can actually just like, it's almost like grouping in Grasshopper. You can make like a box there. You can even color that box if you want. Just to remember that like those are somehow correlated with each other. I like to do that sometimes. Okay. So now we got to do the clip in the mirror for like the next operation. Clip. And we will do the same thing that we did before, is we'll reference from the other, from this one here. But in this case, we don't have to do negative because we're going in the downward direction. So we just literally just copy parameter, but we can't do a reference because they're not the same node. So we have to do the just parameter references. Paste relative reference, and then here too, we want to get the direction. So we'll copy parameter, and then here, paste relative references. So like here, it should bring that all down. Or it should clip it, actually, sorry. Yeah, so see, it's clipping at the point that we set. And then we do a mirror, just like before, so we can create a reference copy of this mirror. So actions, create reference copy. So there's our reference mirror, and that's the mirror here. And I'll make these like a color, I don't know, maybe. Again, just to remember that they go together. Box. Make box that color too if you want. Yeah, so here now, check this one. And this, this operation with the clipping is like slower for sure because you're using like the actual mesh instead of the VDBs. But just give it a moment; it will complete. And there you go. So that's another kind of aesthetic there. I think that's really cool. And yeah, so now what we can do is we can set up a, which is called a, well, first let's bring this back to a VDB, this one here. And we want to use the same VDB as the green groups we were using. We want the same thing. And we can actually, since if we're using SDF, we can actually make a reference copy of this one. So we can actually do action create reference copy of the VDB from polygons of this one, which is funny because this one is referencing. So now this one is referencing a parameter from that, and then this is a copy of this one, which is referencing that. So it's interesting, but they're all connected when you change that voxel size, which is the important thing. So we're going to convert those to VDB again. Same settings. Okay, so now we have our VDB back. You can tell it's VDB by when you zoom in, you have this kind of like weird box things. And so what we can do is we can set up a switch. And just plug this in there and this in there. And so what that will let you do is it's going to let you switch between if you want to use this kind of mirroring or this kind of mirroring. And the nice thing, unlike Grasshopper, it's only going to calculate, Houdini only calculates up until and exactly what it's using. So even though we have these two nodes here, they're not doing anything. They're not being calculated right now because we're not using them. So that's why things can stay pretty light. You know, this right side operation is a bit heavier. But if I switch this, so right now it's using this 0, 1, right? So that's why it completed pretty fast because it's not using this. Even though it's there, it's not computing that because we're not telling it to compute that. If we take the switch and switch it to 1, right? 0 is this side, 1 is this side, then it would use the other side. So, and whatever is dotted, it means that's not being used, okay? So now you can just change that switch. If I just come here, and we can see it like up there in the way that these things overlap. If I just come here and just do 1, I change that to, now you see that this one became dotted because we're not using that. We said, okay, use this stream now. And so now we're using that side where it was like clipped and mirrored, so we don't have those things coming across. So whichever side you feel you want to use, that's the side you should use. I kind of like, for something I like when they kind of overhang past. So I think I'm gonna go back to that one. And again, remember, like now you can change all like the settings and all that and get these to like, maybe you want them to flail out more. Maybe you want to scale the other direction or really up to you. You just gotta just play with all the settings. You can play with this thing for forever. I mean, it's a lot of fun. So let's do we'll do some like finishing stuff. So we'll do some, now that again, if you look here, we have 4 VDBs, right? Because we did like all this kind of mirroring, clipping, whatever. So we're gonna do that union again. So we get a union. How to create STL? Yeah, well, I'll show you how to export when we get to that. So union, and we don't want to combine, we want to flatten all A again into one. So we take the 4, we make it into not cooked yet. Here. VDB clip, because VDB clip requires masks, and I really have the time to get into masks right now, and I can't really connect it easily to the mirror parameters because it's just a different thing. It's not the same operation. So if I look here, it requires either camera geometry or a mask VDB to clip to. So you need to make some kind of geometry. Maybe it's like you need to make a box here, and then like that would be clipped, or you need to mask the VDB and then play with the padding. So it's just a completely different thing that is useful and definitely could result in the same thing. But the thing that I didn't want to do is I can't link it to the same parameters because it doesn't have the same parameters, unless I made like a box and then made distance and all this stuff, which I just didn't really want to mess with. So I just converted it to a mesh. There's a whole kind of set of Houdini that's about like VDB masking and all this stuff that just don't have time to get into. Okay, and then so we have that. So we unioned it into one. Then we can do a reshape. VDB reshape SDF. And if you want to kind of adjust the shaping of this thing, you could do it with the reshape. So there, I just increased it by 1 and made it like I made everything a little bit fatter, which I think is nicer. So I have it dilating to 1. So if I look at it before and after, just a little bit fatter, I thought. Kind of nice. Then we can do a smooth SDF. Smooth it. So now things are getting smoother. We can even more iterations. Play with the filter voxel radius to get even smoother. Like if you wanted like really kind of gooey, I think it starts to lose a bit of the definition. So I'm just going to keep this at 1, just so it's a bit sharper. So I don't lose all that detail in there. And the last thing I just did was convert VDB. And now this is when we'll want to go to our polygon, our mesh. Because obviously, we can't really bring the VDBs out into print or something like that. We need a mesh. So we convert it to polygons. And so there's our actual mesh, looking quite beautiful. And the last thing I did, just for like a last minute thing, is I kind of like wanted the overall thing when I was doing it to have a bit more like depth. So I just scaled it. I just scaled it in the Z direction or something. Just a quick way to two or something. You can just get it a little bit thicker, you know. Yeah, so once you have that, that's basically, I mean, that's basically it for this. And I'll show one more thing. So why don't I just copy this over? Just select something new. So one more Houdini thing. But I mean, despite all like I mean, there's a lot of technical stuff with Houdini. Don't get me wrong. Like, there's a lot of complicated things, but in terms of like general use, it's not so scary. For doing stuff like this, at least. So I want to show another thing, which is I'm just going to say that this is I always put the kind of null at the end too. It's just kind of standard practice. But I want to show something up here when in our compiled block that I was talking about kind of earlier. So actually, let me go to this null here. So why don't we take a last 5 minutes break, and we'll come back. I'll show a little something here about the compiled blocks. I will do a little bit of KeyShot, and that'll be the end of it. So let me save this if you need it, and see you in 5. Okay, I'm back. So, yeah, Mac, I don't know. I'm just gonna uh, educate, educational version, educational for what? Let's say you can change format from Geo to STL. So we went on a break, and also, yeah, I mean, honestly, don't use Mac. If you want to be involved with computer design, just get a PC. Mac is just always problems. Um, so if not, yeah, I just have to find other ways to do things. I guess it's just not for this. It's not for this industry, I would say. Especially with the kind of like graphics cards you have available also for PC for these, it's just like. Yeah. So what I want to look at now is I want to scale these so that they're like less uniform, let's say, and we can do that by, for instance, if I got a transform node. And if I put this transform node into convert VDB, I will be able to kind of transform that shape and then clip it so we can, for instance, stretch it or something. So let me just go here, and I'm just going to change this to a single pass just so that we can see it quicker on one. So if I change the scale of something, which I'm basically changing this VDB here, this thing here. Like we made a VDB, we made a bounding box around the geometry, filled it with this stuff, and then we're like clipping it against each node, all stuff that you kind of remember from before. So if I scale this in, let's say, X by 2, you see that it's scaled. But the thing is, it's like, in this case, it works, but it's not scaling by like the center. So there is a good chance that it could go off. So let me just put this on to show you why I did that, first of all. Is because now you can get like a more stretched out kind of look, right? Everything's like more stretched. So if I went even to like 4, something like super stretched. So you see how it's like much more stretched out, okay? Versus 1. Okay. The problem is that we don't we can't scale by the center, right? So in order to scale something by its center, you have to do a little bit of typing. And I'm just going to copy it and then explain. I have it here. So if I go to transform, you can also type in like code into the input. So for instance, we want to translate the pivot as well. And we want to say that we want to scale this by the center of a box. Like similar in Grasshopper, if you were to take the center of a box and then scale by that center. So what you would do here is like that, right? So that's kind of code. And these are all Houdini things. Like if you start typing, for instance, if you type centroid, right, like it starts to give you like little names, and then it tells you kind of like how you should format it, right? So there's like slash slash dot dot that, and then there's the object that you want to get the centroid of, right? And then there's the dx, dy, dz. That's just like the x, y, z, and we have three inputs. We have x, y, and z, right? So it tells you how to write it. So I don't know why you don't just save the link somewhere, put it in a note or something. Yeah. So we have that, and we want to reference actually box 6, right? Because that's actually the boundary box, right? And so I'm going to reference box 6. 6. I do this here, and this is going to be y. So what's going to happen now is if I come here, we get an error. It won't work. Why is that? Because of what I told you about the memory and compiled blocks. Now we're self-referencing something that we've locked into memory, right? And once we've locked this into a compiled block, it no longer exists as a box to reference. It exists as a compiled block, its own thing. So there is actually no more box 6 in the memory, like for us to reference, and we can't reference externally. I mean, box 6 exists somewhere, but we can't reference it externally into that. So it breaks. So you have two options. The two options are you can get rid of the compiled block and just use the for each, but that's a little bit slower. So what you can do is, in this case, and this isn't the solution for everything, what you can do is you make something that you can reference in the same way that's outside of the compiled block. And now instead of referencing this box, we're going to reference that box in our transform. So now we're going to reference box 7. 7, box 7, because box 7 isn't locked into that compiled block. And now it will work. Okay. So that's kind of like one of the things that you can't do with compiled blocks is you can't reference, like things are locked into that box. You can't reference them. So I couldn't reference this box anywhere, not just here. Like if I wanted to reference it in some other script over here, like you just can't reference it if it's locked into a compiled block. And in this case, we needed that box center. So we just make another same exact box and just have it outside of the compiled block, basically. So that's how you can do that. And then we can transform this all we want. So we can make this like, if we make this 4, it's going to be like super stretched out like that. And so if we come all the way down here, just say, so now you have like this more like stretched out thing. And actually I stretched it so much that it like didn't pick up in like the smaller stuff. But that's cool. I mean, it also looks like pretty cool. So it's just like something you have to play with. Like basically what happened was at some point we're doing it in a road function, probably in one of the, or we smoothed it too much. It became too small and we smoothed it too much away. That's fine too. And this also looks pretty awesome. But something to play with and just something to know about is that like you can, the point is just to understand that error, which is basically like you can't reference something that's within a compiled block. You can't reference it elsewhere. Once it's in the compiled block, it's locked. It's locked in there. and just consider the compile block as its own thing. It doesn't have parts anymore, let's say. It becomes its own thing. So yeah, I mean, that's much that. So just want to go back to 1 or maybe 2. Let's see what 2 looks like. Probably too much scale when I go that big. No, I think I messed something up there. Ah, I'm so stupid. Forget what I was saying about that. It's because I still have on single pass, so I do that sometimes. Let me change it 1 second. So that's why it's only showing that. Which kind of looks cool actually, like with just 1, but it's doing that because I have it on single pass still, so it's only computing like the first block of that and then doing everything else. So want to just come here and take it off of single pass. So just let that cook. There. Now you have this kind of much, these longer pieces of that, which I think looks good. But I'll go back. I'll just make it back to 1 for the sake of this. Okay, so back to this. Now we have this thing, and that's basically it. Now the only thing you have to do is change parameters, and that's how you basically design, change parameters, and change the grasshopper shape, basically. And that's all it takes. So you can, you can now come here and make really any change that you want. Like, let's say that I wanted this to twist or something. Not that much. Maybe I wanted it to twist like that, and maybe I wanted it to be shape like that. Then you would just change it, and then you would just remake those JSON files and go back to Houdini and just go back to your inputs. I'm just gonna click up here while I do that, so it doesn't calculate until I reload both. I'll reload it, and I can reload this one as well. Reload it. Right. And yeah, and then just come back down here, let it compute. And that's how you can make some changes like that. What error do I have here? Did something wrong here? Let's see. Attempt to click on during execution. Sometimes you gotta just like click through the nodes and they fix themselves. Just let that cook. Okay. Yeah, and you also think about like the amount of geometry we're making right now is just like so like the density of everything is just like so crazy. If you can imagine like that's pretty cool with the new geometry. So automatically just by like changing just the grasshopper part, and then you can change all the things like the copies and the mirrors and all this kind of all the stuff, the flow rate of the bob. I'll make this one actually blue, so you remember that's an important node with a lot of different settings that we didn't really play with, but all they do is just change. They basically change this inner geometry, like how that looks. Just change the settings. There's nothing you have to do besides change the settings. So yeah, I mean, just playing with all that is just like a lot of fun. But I think so. For now, I'm just going to go back here to my original settings for the KeyShot. So I'm just going to get those older JSONs back. I changed this curve. Okay. So just make those in. Reference them back again. Let's see if this will work out. Same thing. It's like I have to like. Sometimes things are just weird like that. Yeah. we're gonna go with this. So save. So now what you can do is just right click, save geometry, and then change the type. There's STL there for me. I don't know. Someone was asking about STL. I'm gonna go to OBJ though, and pick where to save it. I'm just gonna save it on my desktop for now, just so it writes quicker. And desktop, accept, and then just accept. And then you just give it a minute. Depending on how heavy or denser object is, it could take a minute just to make that OBJ. Then once we have it, we'll just bring it right into KeyShot. Do you find this stuff fun or interesting? If any of you have not used this before or have used it before? Okay, so it broke my thing. You don't have Houdini. You know, Houdini is free apprentice. It's kind of basically full version. Only difference is you can't output like Alembic, and you can't render without a watermark. But other than that, it's free. I mean, I'm using a commercial version, but yeah, because of rendering. But yeah, you can just download it for apprentice version. So. Okay, so I have my OBJ, and again, in my case, it ended up being like a gigabyte. So it can be. I'm gonna have KeyShot open. So I'm just gonna open up a KeyShot and then save OBJ. Yes, just right-click the node that has the geometry you want to output. Save geometry, and then come to this little down arrow here and select the file type you want to save. And then click this paper with an arrow and click where you want to save it and name it, and then hit accept, and then accept. And we'll start making OBJ. Okay, so in KeyShot, I'm going to pause, unpause it, and I have the OBJ, and I'm just gonna drag it in here. Just going to, I'm gonna keep the position relative, the native origin. I'll adjust the camera to look, adjust environment to fit. That's about it. So I'm just gonna import that. That might take a second too. Not so long. KeyShot's really good at importing these heavy geometries for the most part. Especially once it's past the initial loading, like actually in viewport, it's very fast. So. I don't know why you're erasing it. I don't know what raise hands means. Are you trying to ask? You can just write the question. I don't know if there's any other reason why you raise your hands. Okay, so yeah, so now it's in KeyShot. And what you can do is if you have a good GPU, I have a good GPU. You should go to GPU mode because it's a lot faster. So I'm going to switch over to GPU mode. It's this button here. And so now you can see it like clears up pretty quickly. And then also I'm going to use denoiser. The denoiser makes life so much easier. It just gets rid of all the kind of grain almost immediately. So with those options on, I don't really care about the ground plane. You can see there's like a ground shadow there. You can either move the model up by just right clicking and going move model. And you can just like move it. Or you can just turn off the ground. Up to you. So I'm just gonna do like that. I'll also turn off the ground because I don't really want to see the shadow there. So if you just come over here to environment, and you can just turn off the ground shadows. That. And yeah, and then so the other thing is like you want to just pick like a material, right? And there's just tons. I have a bunch of materials I've downloaded, but there's like just so many. There's just tons of standard materials too. If you want to download materials, you just go to Window, just click Cloud Library. It'll open up your account in the Cloud Library, and you can just drag new materials into KeyShot. So yeah, now it's just about picking a material that you want to render this thing in. Maybe metal or something. It's kind of cool. And the other thing that that's nice to do. Also, my image size, I have it set up for Instagram, which is like a 1280 by 1280 square. But you can just come here to image, and you can change the width and height, and click this link if you want them to be. Want to change them disproportionate. Denoise options here. I don't really ever mess with them because denoiser's been pretty good to me, so I don't really change it. So the other thing is you want to hardware configurations, the most you can afford. That's what I recommend. I'm with the RTX 3090, AMD Threadripper, 128 gigabytes RAM. Can we have separate layer for root and pod? Well, if you do them separately, at some point we combine them, which was here. So at this point here in Houdini, they're no longer separate. So if you wanted them separate, you'll have to basically do everything after this node to each side, or do some different things. But if you separate them, they won't blend together. You see how the meshes blend together, so there's no intersection. So, yeah. So at this point, they're together. They're one thing. Your 380 is struggling. I don't know. I'm doing fine here. You have it in GPU mode. Are you struggling in Houdini or struggling in KeyShot? Yeah, just let me know if you mean KeyShot or Houdini. So yeah, so the important thing also is the environments make a big difference. It's a good environment. You have all these kind of different environments. They really make a big difference in the lighting. So you can, I don't know, we'll just see what this bathroom looks like, right? Obviously, we don't want to see the bathroom in the background, so we can just go over here, environment, and take off the lighting environment. And you can either use an image, a backlit image, if you have one, like a gradient or something, or you can just use a color like that. And of course, you can rotate the lighting, right? You can change that lighting. this is basic material. Yeah, this is, yeah, yep. Material, I want material to metal. I just use a metal, titanium. Quadro, I mean, yeah, I mean, it just depends what quadro. There's good quadros, there's bad quadros. So it just depends which one. Just like there's good RTX and not so good RTX. Yeah, so just, you know, now you can just change the material to like whatever you think that looks nice. Barcho, RTX should be good. Make sure you're in GPU mode if you're talking about the KeyShot. Make, you know, it makes a huge difference, GPU mode. And you can see how immediately that is going. So what else? You can of course change the perspective angle. If you want it to like seem flatter, or if you want it to seem like more exaggerated, something like if you wanted to do something like that. And we can give it like a black background. But the reason I like KeyShot so much is it's like so simple. I don't know. It's just like I like simple rendering edges. I don't like to play with too many settings. I mean, you can get really complex with KeyShot and the node editings and stuff, but for me, I'm just always using like the simplest stuff, which I like. It's like you don't have to be so complex if you don't want to. And then, you know, if you're trying to do something like this, it's kind of like more elongated. You can, of course, use, if you go to the camera, you can go to depth of field. Just click that on. It'll go like crazy like this because we need to set a target. So you just click this little target and then click somewhere close like that. And then you can set the f-stop. Just try 100. So I want to reset. So I'm going to click this like the focus. Maybe I want to be like here. So I'm just going to click there in the model. Then maybe I'll make this like 75. So you get like that kind of blur in the background, which is always kind of nice. And if you want to get even more like blurry, give it something like that. Yeah, you definitely play with like the HDRIs makes such a huge difference. Like downloading, there's like a lot you can download to, or just playing with like the environments too. Like I'm using this bathroom right now. Like you can change it to this, like this. You can change them all. Use HDRI. I think I downloaded some too. There was like this kind of purple one that I was using for some stuff. We make curves to be. I think so. Yeah, in the library, yeah, exactly. In the if you go to Cloud Library, there's also environments there. That's where I got these ones from. Some of them can take longer than others, like this 3-point dark 4K is really nice. Be a little bit heavier. And you can see how it's like kind of like weird up there. That's just because it's not done yet. That's just that the noise are like looks blurry. Like blurry in a like weird way at first, but it clears up usually. And that, I mean, that's mostly what I use. I mean, for KeyShot, most everything I do is in KeyShot, and it's like very basic use case. I like the bathroom one, I think, the most. And then you can also change like the lighting preset too, like the product interior. Interior kind of looks nice too. I think that's pretty nice. Yeah, playing with just play with the rotation of the lighting, the height of the lighting. You can play with the height of the lighting. And it all depends like what you're kind of going for there. And so when you want to output, oh, my GPU is off. That's why I was wondering why it's taking so long. So then let's put this on something like this. Spend time like positioning things. Okay, so once you have the thing, then you can actually render it. So just go to render, render. I always have the resolution. I'm usually using like 150 dpi, and then the resolution I'm usually using. I'm usually using twice what I set as the image size. I like to. So I like to, so my image size here is 1280. So I'll do at least 2 times that. So I can do 2560. And then options, I always inherit from real-time view. I'm usually in GPU mode, so it's going to use a GPU 100%. And then quality, I use max samples, and I've been using 250 a lot. I think I forget what KeyShot's default is set to, maybe 50 or 30, but I bump it up a lot just because I have the GPU to do it. And when you use a lot of samples, you can get like some really clear images. So the samples really matter a lot. So once you set those, all you got to do is just hit render. Don't worry about the recording, you'll get it. It goes to registrants. So then we just render. Yeah, it's almost done. So it's like render that whole thing on the GPU. Took 30 seconds, pretty high quality. So so here it is. It's pretty clear. So. And yeah, I think that's about it for this webinar. I hope you enjoyed it, learned some stuff, found it interesting. It's certainly interesting for me to come up with. Just doing a last save on everything just to make sure that you have everything. I'm not going to save. Well, save. I'll save the key shots, but could be a bit heavier. Let's just save it. Save it pretty quickly. 530 megabytes, whatever. Yeah, so I hope that you all enjoyed it. So after this, when this recording's ready, it usually takes about the same amount of time or double the amount of time of the actual webinar for Zoom to process it. It will be sent to email you registered with, and also we're going to pick the winners of the prizes randomly from the Zoom gives us a registration list and also a live attendee list. So it will get picked from there, and we'll reach out to you if you won. The 3 prizes are 3 people will get free access to our next 4 webinars. 1 person will get a Foundation app invite for a creator's profile to mint NFTs. And another person will get a free full license of KeyShot from KeyShot. They so nicely reached out to us and offered it as a prize for this webinar. So we're thankful for that. I don't know if they're here in attendance or not, but we're really thankful for that. This is really cool. And yeah, if you want to see more cool stuff, don't miss the next webinars. You know, they're not free, but they're not really that expensive, and they're definitely all up to par. Don't miss out on those, and check out our master's degree if you're interested in computational design as a profession. Thank you all. I hope you have a good holiday, whatever you celebrate. And so yeah, I think we'll end it here if there's no kind of pressing questions. I'm not sure what this. You're raising your hand. What is it? Do you want to speak? Is that what you're telling me? I don't understand. Can you write it in the chat? Like what do you want me to? What do you want me to do? I don't know what you want me to do. Just let me know before I close it. Let's see if there's participants. Yeah. I mean, if you really want to speak, you can speak. I can put you on. These skills all the time. Maybe it's clap. The recording won't be in the chat box. I mentioned it will get the email. We'll get the email. Industry, any industry. I don't know why it would need to be limited by industry. Anywhere you can do a 3D software, you can use any 3D software. Well, you can always watch the recording if you couldn't make it for the whole thing. That's okay. And you have the files too. So. What's better than that? Where is the recording link? I'm so angry with your caps. It'll get emailed. Don't worry. What's recording? There's no recording yet. It's not ready. All right. Well, thank you all so much for coming. I'm really happy that you all attended. And good luck to you in hopefully winning some prizes. But at the very least, you win some education and recording and files. So, something to do over your holidays. Yeah, I'll end it now, and thank you so much.